Buildspace stuff today. I think I figured out what the problem is that I'm having when using Pixi viewports. I think the problem is on the React-pixi, and it makes a lot of sense to me now. But I'm not 100% sure if it is the problem or not, but I think I have a good idea. Like a good, at least that there's a path to solve in my mind now. So I think what is going on is that Pixi.js updated the library, and they moved from the interaction thing to the event, and then Pixi viewport updated from that point, so it's up to date, but then React-pixi didn't update it. And that's the reason why I am getting the deprecation warnings there, is because it's coming from Pixi React itself, because they haven't updated the library since the Pixi.js made the changes. And because Pixi React relies on Pixi.js, it breaks the thing. So it still works when you just use Pixi React, but if you're gonna do anything related to events, it starts breaking because it has the older version. So I think the way that I'm gonna have to do to solve this, like, there's two different approaches. One is to try to make the other libraries go back to the previous version, or install a previous version of the other libraries to use the interactions instead of the events, which I don't think is really good. Or the other solution is to just download this library locally. And instead of using the source code, I just put the source code into files in my local project, and then I change the source code so that it works and starts using the events instead of using the interaction manager thing. So that's what I'm gonna do today. But obviously there could be several different problems with that, and the main one that comes to my mind is the import. And then on top of that, I'm gonna have to understand how the file really works, how this thing here. But I think luckily it's just one file that the project has, because everything is inside of this file. So I think I can just copy this file and then I import. Like, I put this file here on the components and I import the file instead of importing the project, and hopefully that will work. Then after that point, I can just look for the code here. There is a part that I already seen that has the deprecation warning. But I think before I do all of that, I'm just gonna spend some time training touch typing, just to get into the state, to the mood, because I'm planning on staying here for a long time today to solve this stuff. So yeah, hopefully that will solve the problem. I think that's why some of the events are working and the wheel is not working, because the wheel is the only one that uses the events from the app renderer. The other ones are on the class itself, on the Pixi viewport class. So it works. And is the whole thing about the way that they did it, because I think that they create a custom renderer in Pixi React. So the way that manages the state is different. And then on the life cycles of the state, because of the, there's probably some problem with the hierarchy of classes, because I'm using the events. So even though it exists on Pixi.js, because React-pixi is using Pixi.js, the way that it mounts and unmounts components, it makes it so that the thing doesn't exist at the time of the event, I think. But it's probably going to take a long time. It's going to be difficult to figure out. But I think at least now I have a direction of what to do. I think what I'm gonna try to do is just download this thing first and put some music as well. Yeah, this is the issue because I don't know if I need to download a bunch of other stuff to make it work. Maybe using the source code from here is better than uh, just copying the file. Here it seems that it is on separate files. Reconciler, interesting. Yeah, I think I'm gonna copy this project there. There's a lot of stuff here though that it's not useful, I think, if I'm gonna use on my thing. That's the issue. Maybe I can copy everything and then I remove the stuff that I think is not necessary. So it's probably much easier to understand from this code here. Because the one there that I have is the compiled version, obviously. I think. This is the reason why I was searching for, because I want to understand. I was searching for the how to build these libraries. I want to understand like what is the process. So like how is it possible that the version that you have when you download directly from here is different than the version you have when you use a package manager? So I want to understand that. Because you have the compiled version there, but it also the file that I'm looking at is the development version. So I want to understand how, like, what is the process of how does the person that creates the library allows it to how they decide which files are gonna be downloaded through Yarn. Yeah, but it looks like this. Oh, like this project is the development version, and then the file that I was looking at is the compiled version, not compiled by Webpack, but when you put everything together on the same file, even though the structure is similar. I think after Webpack compiles the code, then it becomes almost impossible to read because then it's just a bunch of letters. So it's very different. So I think there is both the compiled version there and the development version, which is just putting everything in one file, all of this code here. So here it is using the reconciler. So I think that maybe this package becomes something else on the other file that I was looking at. On this one. Because here is not importing the reconciler directly. It has the React reconciler, but it's inside of an object there. So I assume there's something that it happens when you use Yarn with the way that the modules are structured. Reconciler. And those are all the configurations. And here is the package. So assume here it creates the dependencies. It's kind of like creating package JSON, but manually creating here somehow. Yeah, package, then there's the stuff here. So imagine that this file is the consequence of putting all this project in the same file. Generated by CoffeeScript. Yeah, so now I have to think about like what I'm gonna do. And should I use this one? Also, I wanna delete a lot of the stuff here. I think this sandbox doesn't really matter for stuff that I'm doing. I try to delete as much stuff as possible. Maybe I should open this on the File Explorer here. Also, I should delete this, and probably Rusky as well. And then the packages. Packages is the stuff that has the code. The script probably should delete. So this is the stuff that I want to understand more. Is like on the package creation side. So I think I'm gonna watch some videos as well at some point. Should I try to understand that? What happens when you use Yarn to, like, how do you make a package available, and then what happens? How do you decide which files are gonna be downloaded through Yarn? I think this stuff's probably not necessary as well. So I'm gonna delete this. The share thing, I'm not really sure if it's necessary or not. And the other stuff is just related to configuration. Maybe I'll leave the git ignore just in case. But I think, like, yeah, there shouldn't be anything here that is dangerous, sure. So I think I'm gonna delete as well. And all these other files, I think it doesn't matter as well. Because I'm already inside of another project, so these files already exist at the root level of my project. So I don't think it matters. As these files here. There's some extra stuff they use there, which I'm not using. But then I can just add later if I want. So let's see. It's Babel. This is for testing, I think. Yeah, pretty sure it is for testing. Babel is the transpiler, I think. It's probably for transpiling the code, which is the process, I think, of getting all the code from the files and transforming into one file. Common.js, Babel replace. I think I can delete this folder as well. Yeah. Blah, blah, blah. This is the one that I'm not really sure because this is probably used to for the reconciler. So I'm gonna have to see. I'm gonna delete this one as well because it's probably useless. Animated, not really sure what it is. Hmm. Yeah, this is the stuff that creates the host. So it has to do the reconciler, I think. But I'm not really sure if it's relevant. So I have to see if the other files use this. I think this is another project. And this is the same file that the installed version has. So I think that this creates the files there. I'm gonna delete and then if I need it, I'll install again. I just want to get the files that are necessary and delete everything else. So the annoying thing about this is gonna be that I'm gonna have to change the imports there, I think, on the main file that I'm using. Because they are located at different files. As everything is exported from here. Yeah, so maybe I can just import from this file, I think, actually. Mm. So let me think. What should I do? And the thing is, like, it's hard to know if I should keep these files here, because I think that, like, the way that this project is structured is so that when you use the package manager, it's going to construct the files there. So if you're using the files directly, I think a lot of them are not necessary. And I think these are the tools that transform the code there. Just babel and rollup. So this uses the shards. Cool. Which is this. So I think this is the file that creates the final version. So like all this stuff here probably gets this whole project and transforms into this file here, and the other one, like the ones that exist inside of this. So it transforms into this one. So let's see here. Yeah, there's the index. The license doesn't exist, but it's probably created in the readme and package.json module.js. So it's exactly the same files here. Yeah, so that's what creates the file. Format. Get build format. So the shared is the stuff that creates the file. I'm just gonna close all of these files. So I think it's not necessary, but I'm gonna research the stuff before I delete, so I understand how it's constructing the code that I get on the other file. So this is gonna be the destination, which is this path here. Just creating these files here, index. Let me see the other name. And then the format and the build type. Interesting. Builds, blah, blah, blah. Yeah, so I think I'm gonna use this project because it's probably a lot easier to understand what is going on, rather than using the other file. And then I can just import from the exports here inside of the source. And then I'll just go to the files that are outdated and I'll manually change the code. It would be nice as well to spend some time to see if I can make a pull request to allow them to change this stuff. I have to see if the code they have here is gonna be the same. I think it is. It's the same thing. And then packages. Hmm.
Hello everyone, my name is Mitch Vidnik and I'm a developer advocate for Facebook open source. And today I will be explaining the project DocuSource to you like your 5-year-old. DocuSource is an open source project for building, deploying and maintaining websites. With familiar tools like Markdown and MDX, developers can feel at home while using DocuSource. DocuSource supports documentation search out of the box with Algolia search engine built in. For sites that support multiple languages, DocuSource allows for an easy integration with a service called CrowdIn. Last but not least, DocuSource supports versioning of the docs, so you can keep your site in sync with your code. DocuSource was first released to the public in 2017. Since then, this project has been used by a number of Facebook and external projects. Would you like to learn more about DocuSource? DocuSource has an extensive documentation and tutorials covering a variety of topics on building and customizing your site. If you want to engage with the community, feel free to join the Discord channel or contact the team on Twitter. If you want to see more about DocuSource on this channel, give this video a thumbs up. Thank you for watching.
Maybe it's good to keep this stuff on the on there, even though I'm not really sure if I'm gonna use it. Yeah, like it seems like it's a different version, and then you can do different things. I think it's for animations, like the name says. So I remember seeing this React Spring there. Maybe I will use that in the future. So the animated version here. So, oh, did I delete that already? Oh no, here. Yeah, so there's React animated. They're both inside of the packages. And the other stuff's probably not necessary. Yeah, so just gonna move this from outside of the packages. I'm gonna put in the, and then I'm gonna have to refactor all of the imports, probably. I think I'm gonna close this stuff. But this is actually much better, because here is more confusing. Yeah, that's probably the better approach, to just use these files here and then change the code instead of copying this one. But I'll test. If it doesn't work, then I will just copy the file. And the main question is whether or not I should keep this shared here. I don't know if it makes sense to keep that or not. I think I'm gonna study the stuff that they are using to create the code to understand, and then after I study, I'll delete everything and just leave the what's necessary, like the files with the actual code, and then like this stuff for the tasks as well. I'm not really sure, But maybe, yeah, I think it doesn't matter that much if I just leave it there. Like tests is something that like it doesn't really feel right to me. Like it seems like something that is kind of a waste of time, but it might be just because I haven't worked on very big projects on the team. But it seems like doing extra work just for the sake of doing extra work. Like because I don't understand like the philosophy of doing the tasks. Because if you are able to create a task that is gonna fully test all of the cases, then it's very likely that you would be able to think about the mistake that can happen and debug the mistake. So like you can only test for things that you know, let's say. And if that's the case, then it defeats the point of having the task, because then you would be able to debug it. But maybe in very complex systems, then like it's possible that you can create some tasks that will allow you to catch things that you are not aware in the system. But yeah, it's just, I don't know. So far I haven't seen the point of doing or creating tasks for anything that I do, because I can just understand what I'm doing and then like build or correct mistakes. And if I was capable of building the task, then it would mean that I would be able to fix the code before. So it defeats the point of having the task in the first place. But I can see, yeah, I can think about some cases why it would be useful. I think the poker stuff is a great example. The poker thing that I was building, because there are so many different things. Like if you change the string, for example, that you're receiving, it might break everything. So, and like the hardest bugs are the ones that don't give you any error. They just give you the wrong output. So it's very hard to know like what is correct. So I think, but it seems like one of those things that it feels like a waste of time to build it. So I avoid doing it. Yeah, I think these files I'm gonna delete all of them after I study this. And I'll probably have to install these dependencies. So I'm gonna do that right now. This is another thing that I don't understand how it works really well. That a lot of the times when you run these libraries, you don't need to install the dependencies directly. So I don't understand how that works. But I guess like what happens is that when you install the library, it installs the dependency, but it installs them locally. But maybe not. Yeah, because here, like there isn't npm, there isn't node modules here, so like I don't understand how is it possible that it depends on this dependencies, but then if you don't have them in your project, it still works. So what is happening there? but it's one of those things that is really hard to search for because I don't know what to search to find stuff related to that. I think this one I'm gonna delete right now. The readme I'm gonna delete as well. I think the rest of the stuff I'm just gonna install as it complains about it. Like all of this stuff here. The rest I'm just gonna leave it like this, I think. Close this stuff. Close here. Mexico. Yeah, so first what I'm gonna do is just search for this. I'm gonna study how it works. And it's this file here. It's because it's the wrong path. There we go. So I'm gonna search for videos about this stuff. But first I'm gonna do some touch typing. Or training typing. So I'll be right back. Then after I train typing for some time, I'm gonna study this stuff here from this file to understand how it builds the code there on the other file. Then I'm gonna change the imports to use the one that I have locally here, and then I'm gonna fix the thing by looking at the source code, seeing how can I change the source code so it uses the event instead of the interactions, because I think that's what is breaking this thing here. So I'll be right back.
Living in hell, only a few of us are here to tell. Now everybody talking about us, I could give a fuck. I be the first ones to bomb and cuss. Nigga, tell me how you want it. Tell the truth, I got the scoop on how to get a bulletproof. Nigga shots up from the roof before I was a teenager. Mobile phone, sky pager, gang rules. I'm living major. My adversaries is looking rugged. They paranoid and people bug. One of us gon' see the cemetery. My only hope is survive. If I was to stay alive, getting high, see the demons in my eyes. Before I die, I wanna live my life in ball. Make a couple million, and then I'm chillin', fade them all. These taxes got me crossed up, and people tryna sue me. Media is in my business, and they acting like they know me. But I'ma mash out and peel out. I'm with it quick, that's quick to whip and fucking steal out. Yeah, nigga, it's some new shit, so better get up on it. When you see me, tell a nigga how you want it. How do you want it? How do you want it? How did you feel? Coming up as a nigga in the cash game, living in the fast lane, love for real. How do you want it? How do you feel? Coming up as a nigga in the cash game, living in the fast lane.
Just gonna focus on accuracy instead of speed.
Welcome back. You're now tuned in to Cars Matrix Radio. That's right, coming to you live from outer space. We're bringing you the tunes to make you rock your body. This one goes out to all you sexy aliens out there.
Are you ready for the ride of your life? Come cruise with your boy, yeah, we ride in the night. My space cruiser is a drop top. Ride around town in a hot box. You're my dream girl, want you on my team, girl. Like a ring, you got me.
Oh,
wrapped
fuck
around
is this,
your
man?
finger. Come with me, girl, let's create a dream world. You and me, moonwalking on the moon, girl. Baby, come with me in my space cruiser. Let's get faded. My space cruiser.
The fuck is this music?
Name, man, I ain't fucking playing. I move on you with that mag, man. Come up there, watch your chain. Before I blow out your brains, shells at your chest, go out your back, man. See me, I put in work, man, I've been doing dirt for so long when niggas get laid out. Niggas run through my crib, to holla at the kid. That's when I start bringing them things out. Then we go through this strip, hanging up out the whip, dumping clips off at they whole clique, man. With witnesses around, they know how we get down. So when the cops come, they ain't see shit, man. My soldiers slinging canes, sunny snow, we sleet the rain. Come through the hood and you can cop that. I'm sitting on
I'm a rider. I got a hell of a aim. I keep on telling you, man. I swear ain't nobody gon' find you. When I get lifted, I'm tempted to tell you, block up. Your niggas can't run, cause I'm behind you. Me and Chili in your city with a couple 9 millies. You better stay in line, bro. Cause if I walk it, I'll talk it. You know we'll walk up and pop it. My love the sound of gunfire, bro. Right now we smacking them with platinum and they hate it cause we made it. That's what we keep that iron for. I represent it cause I'm in it. UTP until I finish. Juvenile, they can't stop us. And I admit it, I live it. I knock a ball off his pivot with this motherfucking chopper.
I love the pump crack, love to stay strapped, love to squeeze gas, but you don't hear me though. I love to hit the block, I love my 2 clocks, love to bust shots, but you don't hear me though. I love the pump crack, love to stay strapped, love to squeeze gas, but you don't hear me though. I love to hit the block, I love my 2 clocks, love to bust shots, but you don't hear me though. My 20 inches spinning, you always see me grinning, and you hear niggas call me grimy. They hit me with them bricks, and I ain't paying shit. I'm out of town, they can't find me. When I come back around, man, I'ma back them down. I run up, bustin' that tech, man. If you ain't got a gun, and you can't fucking run, my advice is you hit the deck, man. But if you get away and come back another day, my soldiers will leave you wet, man. Cause we know where you be, and we know where you stay, and we'll come tripping through your set, man. Man, you heard what I said, now get it in your head. I ain't paying no fucking debt, man. Cause you's a middleman, what you don't understand, you's a fucking fake ass connect, man. I love the pump crack, love to stay strapped, love to squeeze gas, but you don't hear me though. I love to hit the block, I love my 2 clocks, love to bust shots, but you don't hear me though. I love the pump crack, love to stay strapped, love to squeeze gas, but you don't hear me though. I love to hit the block, I love my 2 clocks, love to bust shots, but you don't hear me though.
That flow through you. I wanna be thrown into your tide. I wanna become like you and move the way you do. I wanna be thrown into you and go wild. Sirens flicker around your head. Tonight, you can see them calling for my silent hands to come alive and to tear this wall. And sirens flicker around your head tonight. Let the sound come down on you, down on you.
A lot of the times I get these errors because the keys get kind of stuck on the keyboard. A lot of them are not because of that, but some of them, like I think the M on the keyboard is kind of a, it gets stuck sometime, some of the times. And like right now, for example, the C, or try to pass and then gets stuck.
I just wanna turn into the darkness that beats in you. I wanna surround you like a fire.
But I have to focus more on accuracy so I can go faster later. Because I think that accuracy is fucking me up. It's like capping how fast I can go. It just messes up the whole flow of the thing. Because the faster you go, like you start having to read words ahead, and then you kind of get into a rhythm. And then if you get one wrong, then it messes up all of the other ones. Because like you're expecting in your brain the other patterns. So usually the mistakes compound.
Sirens flicker around your head tonight. I can see them calling for my silent hands to come alive and to tear this wall in. Sirens flicker around your head tonight. You can see them calling for my golden hands to come alive. To tear this wall in. Sirens flicker around your head tonight. Can you see them calling? Sirens flicker around your head tonight. Can you see them calling? Sirens flicker. Sirens flicker. And the sirens flicker. And the sirens flicker. I wanna be thrown into the rivers that flow through you. I wanna be thrown into your tide. I wanna become like you and move the way you do. I wanna be thrown into you and go wild.
So for example there, like once I get one wrong, it starts messing up everything else because like it fucks up the flow. And then sometimes you have ones where you just get everything right and then it feels like you pick up momentum and it goes a lot faster. So I think accuracy is really important. So I have to focus on going a lot slower and making sure that I'm getting all the wrongs correctly, all the words correctly. I think I'll take a break. Come back later. So let's see if this works. Next.js. It's the source one that I want. Compiler, index, package. So for this one, I'm gonna look into the code, I think. Maybe is that Pixi React? I think I'm gonna look into the repository. Then reconciler. Yeah, package JSON. Yeah.
Feels like I'm waiting, like I'm watching you fall love. Dreams where I'm fading.
Swan trajectory.
So free my mind. All the talking,
Not sure if it's this one or the one in the other level.
I've given all that I've got.
It could be this one. So let me see if I got the levels correctly. So one. There's 4 levels. So the same level would be here, 1 level above would be here. And 1 level above that would be here. 1 level above here. So it is this one. Where's the version though? So maybe it's not this one. I wonder if it matters though, because I think the only thing that matters is the React DOM version. But not really sure, because the other stuff is gonna be more for like the official library. So like to structure when you download with Yarn, I think. So it doesn't matter that much, I think. Yeah, anything more.
If you want me, if you need me, I'm yours. If you want me,
It should be this one,
if you need me,
the correct package JSON. Now here there's no version.
if you want
I think I'm gonna leave it like this then. Package name, roots. I have to do this. I think I'll be right back. The interesting thing is that now the dragging is not working. That's really weird. It must be because of this. And I'm getting the deprecation warning. So let me think about it. So now, like, why does the dragging doesn't work now? It's weird. Still doesn't work. It is obviously working, the Pixi component, otherwise it wouldn't be. It would give you a warning or something like that. So just have to see what is the difference. It's the same function but another place. It's pretty much the same thing. It must be because of the life cycle. How is this one different than the other one that I was using? Like now the dragging is not working here. It doesn't. So it's breaking this thing here. It must be because of the life cycle. So what I have to do, let me focus on the wheel first, because now the other one is breaking, so I have to understand. Like they're obviously, I think the core of the issue is that the life cycle of the thing. So depending on the way that you create the components, because it's creating the reconciler, like a custom renderer, using the reconciler. So depending on the way that you create that, it fucks up the life cycle. And the Pixi viewport is adding the events based on the cycle of the state of the application. So, but like, yeah, and I spent a bunch of time yesterday trying to understand, but I still don't understand really well. And I guess it's because I don't understand very well how the event listeners on the emitter tree work. I don't understand if they treat, like, if you need to emit an event, or if just by assigning them like this it already triggers them. I think that this is the case. It has to be because of the execution, the way that I followed the execution. So this was the thing that I was giving one of the warnings. It's because this is trying to access the interactive, but it doesn't exist anymore. It's using events. So now instead of interactive, you have to put this event mode. So let me think about it. I could ask that in a better way, but it's gonna log in again.
Life is all about you, and not at all about you. Now that's two opposing thoughts, and yet both of them are true. How can you experience everything you choose to do, while observing the experience you're having from a higher view? See, it's the question, not the answer, that's the higher view. Otherwise, you couldn't differentiate between the two. Awareness, but of who? You think you hurt me, but I promise I was letting you. They say we're all one, but where have we been heading to? I'd rather die free than have to live inside a petting zoo. I am the journey that I'm getting to.
I guess it's setting up on the container, because viewport extends container.
gratitude is my destination. My destiny is perfectly aligned with this location. I am the map, so I travel back in time. I have everything I want because my imagination is mine. But mine is not enough for me, because I am not my mind. I could see it all, but never get to see I'm truly blind. I could be it all, but all identity is intertwined. The moon is only bright as it reflects the sun's shine.
I guess I need to understand how this stage creates the handles the container. Stance display object.
It's not the human race. It's just the human race. There's nothing left to chase. We do not run this place. But both medicine and poison's an acquired taste. So I started taking selfies of somebody else's face.
Tell me something. What is more genius than a child's laughter? Are we not simply the children of this world?
Everything I see is a reflection of
I think I'm gonna focus on the wheel first. Just wanna solve that, then I'll think about the rest.
an illusion in my head. In a forest of
So I need to figure out
moon inside the tree.
what is the part that is creating. I'm gonna start from this stage,
That is who I
the part that is creating the interaction there.
might adjust
I think you can follow the stack trace from
away.
these messages here. Component mounts.
There's a room I started building on the day the light came crashing. Every corner holds a truth, but they can
And that's the message that I need to find.
Childhood is a cup already empty once you taste it. When the future is unwritten,
There's this point here. Component data update.
crashing over matter into space. All I am is a wave, waiting on the day for me to break. Everything I see is a reflection of my ego.
This is exactly the part that is fucking up, I think. It's very similar to the way that the other code is. This is the part from the fiber, I think. The React DOM fiber. Just scheduling the work, and then it commits the... When it commits the layout effects, when I execute the stuff.
I surrendered to your beauty in my naivety, and I fell on the honey trap.
Looks like there's rain up ahead, like there's a crack in the heavens. Feels like my day could be turning, like I can tell that my luck's gonna change. If you could see me now, I'd probably let you down, but that's enough for me. You got me begging, baby. Looks like I'm on my knees again. Feels like the walls are closing in. Looks like I'm on my knees again. Looks like the tables have turned, like there's a change in the weather. Feels like my time is returning, like I'm about to get out of this cage. If you could see me now, I'd probably let you down, but that's enough for me. You got me begging, baby. Looks like I'm on my knees again. Feels like the walls are closing in. Looks like I'm on my knees Looks like I'm on my knees again. 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 Looks like I'm Looks like I'm on my knees again. Feels like the walls are closing in. Looks like I'm on my knees
I think I understand what is happening, but it's not the specifics. And that's the problem. I don't understand how it becomes a function or a class here. Because it should be a string, the way that I'm interpreting now. Like I want to understand what this is gonna return, because I wanna figure out what is the path should the render here, because I think that the problem is that the application renderer is using the plugin system, and then the plugin system is using the interaction manager thing, and then that's fucking up the application. So here, like, this is the problem here. It's using these plugins, which it uses the other stuff by default, which is the way that it handled the events before. But now, because they changed, it's fucking up, I think. So I need to access the file, like see where the file that uses this thing is. So I know how to change this code here so it uses the correct events. Maybe it is as simple as just changing from plugins to events, but I wanna understand how it works, obviously. I guess I can try to change and then I'll see later. Like I can do this instead. Render events. But I wanna understand how it works, obviously. And it might fuck up because of this thing here. Or maybe I should change the key so it is event instead of interaction. Like, I need to understand the whole flow of the thing. To understand how why this is being called. And how is that related to the wheel event on the view part? It's obviously on the cycle, and this is called on the component did mount, I think, which happens after the component mounted, obviously. So I think that the wheel is triggering the resize event, and then it triggers this part of the cycle. I think that's what's happening. Because, like, on the select trace, the problem is on the function inside of here, which is the resize event. So I think it does change. The event listers do change the state of the React application. So every time there's a change there based on the event listers, it's gonna trigger these functions here. Just gonna update size and then render stage. And then it's on this one that is fucking up. They don't have the resolution on the options, so it gets to this part. Then it gets the pixel, then calls this stuff. And then here, because the library, the Pixi.js changed, but React-pixi didn't. So this part fucks up. It's still fucked. Oh, but now it doesn't show the thing anymore. So maybe I fixed it. I think I fixed the application, but it's still fucking up the thing, which is a bad thing. Because now it's gonna be really hard to debug this. Because I don't have any clues on what exactly is causing this. I think it is because of the life cycle, it must be. But it's very hard because I don't understand really well. Let's think. So, how can I approach this? Well, obviously it doesn't have the thing here at this point because of the life cycle. And system. But how do I fix? think I'll be right back. Think soon I'm going to read something. But I think that the approach that I'm going to take now is just to try to understand how the Pixi component works by looking at the source code in here and trying to understand the cycle. Like, how does it work? So obviously I'm getting everything from the index there. Because, let me think. So I have to understand how the, okay, at what part of the cycle this is being triggered, if it is being triggered all the time. I think it is, because it mounts and unmounts components during the life cycle. So this is being triggered at one point of the cycle, and I think that the application is like on another point. So it's like two different cycles. So I think they are out of sync probably, because initially it works and then it messes up. So because I'm initializing this in here and I need these events to exist, I think that's when the function is being triggered that calls this thing here, the component doesn't exist anymore. So it probably has to do with the part that I was changing there. And this is the file that I think I am using there. So it comes from utils elements, which is this file. So what I have to do is understand at what point of the life cycle this is gonna be triggered. And then I have to understand how like why when the function on the wheel event function triggers, why does it messes up here? A Pixi component type lifecycle. So lifecycle is going to be an object that takes the configuration, creates, which is a function. This is types injected. So I want to understand what is creating the components. So I think what I have to do is put the did mount here to bind the instance. And this is probably the function that is being called to create. I don't understand yet how, like, where is this called to create the components. It probably has to do with the reconciler, but I don't get why, like how. I guess it's something that happens under the hood because the library creates the reconciler when you import the library. But I'm not really sure about this. So I think I need to put the did mount there. And then, but then I have to think about how, like, what kind of stuff do I need to put inside of the did mount. Because that's probably the issue. Because it's happening, the updates, the triggering, calling out the function that is triggered by the wheel is on the did mount part of the cycle, I think. So by that time, because I don't have this thing, the instance is not binded to this injected thing here. But I'm not really sure if that's the case or not. I think I know what to do. I'm just gonna return this new view part here. And then on the did mount I call the, but I'm not really sure if I can do that or not. Yeah, maybe I can do I call on the instance. I think that's what I'm gonna try to do. So here I just return this stuff. And the question is, how do I remove the the events. Let's see if this works first. The thing is, I don't know if I should return here or not. I guess I can try it both ways. It's still fucking up. Right element. Yeah. Well, let me see if the other ones... I think they're gonna be fucked as well. Yeah, I can't drag. If I do the other ways, probably not gonna change anything. Yeah, I can't drag. Let's see if I do this. The question is, how do I make it so that the app is like the cycle for the app happens first? As I think what is happening is that this life cycle of the app is happening before after This is what is going on. So it tries to remove after the app is already removed. How is that possible? Doesn't make sense. Because the Pixi needs the app to be instantiated. That's what I don't understand. It's probably because of the reconciler. Yeah, that's the thing. So it creates container and updates. So I have to think, what is creating the lifecycle for Pixi view parts? Is the normal React cycle, I think. That's what I need to figure out. And it's from the React component. So it creates the application here. It's creating the application and creating the container with the reconciler when the component did mount. See if there is on mount here. So that's the other thing. So let me think. Because by the time that like what doesn't make sense to me is that I'm using the same component from the library. So how is it possible that they are out of sync if the Pixi view part is inside of the custom component? Like the custom component should happen at the same part of the cycle as or like after the app. This is what it is not adding up, I think. I'm pretty confident that the problem is the differences in the cycles, the way that the cycles work. Because the app is unmounted and mounted faster, I think, than the custom component. And that's why when it tries to remove the event listener, it doesn't have the element anymore because the app was already unmounted. But how is this possible if I'm using the custom component? Like the custom component should be only unmounted. Should be unmounted before the app is unmounted. So let me think about it. And it doesn't make sense to me because like in the code that of the custom component directly, there's nothing that says like that would explain how it creates the component. Because it's probably happening under the hood, the way that React creates the components. Just gonna be the object and it's passing the element, the props, and the children. So let me think. I have to see. Or create elements should be. This is the type, the props, and the children. But in the custom components, concealer primitive components. To tap into the React reconciliation. Yeah, I think this is the key to understand. How is it possible that I'm passing? Because this is different. Like, obviously, this is not props, it's just the life cycles. So I have to understand more how the reconciler works. This is the video that I was talking about before. It's really good. I'll watch this again. But I think this is the key here to solve, hopefully. And close this. So the key is understanding the cycle, I think. It's pretty sure that that's what's happening. So obviously when I put there the config, the mistake is in a different place. And what this does is auto-destroy its own mount. But let me think about it. Yeah, so this makes it so that the function is not triggered. But if the function is triggered, the one that is going to remove the event listener, then the element doesn't exist. So it means that the element amounts before this component amounts. That's the problem. So like the app amounts before. So I need to figure out how to make the app, the custom components only amount after the app. And it might be changing, so I need to understand like how to pass the cycles here. The thing is that like this doesn't give me much clues because I don't understand how this is related to the reconciler. It's just creating the value inside of the object with the lifecycle. So it's just the name of the component, the primitive, and then the value is the lifecycle, which is the object that contains the keys as the functions, and then what is going to happen. But the key is the part of the cycle, and then the value is the function of what happens at that point. So this is adding the components. Through this thing. So it's pretty much mapping the elements through this. And the elements is gonna be an object that contains the values. The key is gonna be the name of the thing, and the value is gonna be the component, which is the function for each one. This is the element. So I have to see where this file is used. I think the thing is that is weird is that I don't think that this is called there on the stage, but maybe I'm missing the part that is called. So let's see. And just see if elements exist. Yeah, it doesn't. So this is the stuff that I don't understand. It's like, how is it possible? Because like this file should be the one that, because this is the one that I'm importing there, and that is gonna create the stage. So it should be the class here. So the initialization of this class should have, but maybe it's because it's extending the React components. So like at the low level, this is just gonna become a object that has the functions. It's gonna be pretty much using this thing here, create element, based on the life cycles here. So essentially it's gonna build everything that is here, and then this is the thing that, I guess that it makes sense because it is using the reconciler here to create the container. So that's the link, I think, between the two. And Pixi fiber is just gonna be from the reconciler here. So I have to understand how this works. And create elements. Yeah, this is the file that I have to understand, because it's gonna use the host config to create the reconciler. Yeah, roast config. And then I need to understand how, when it's calling these functions, it's gonna change there. How like this function is gonna work. So I guess I can just search function by function here, just see, understand how it works. So this happens at the component did mount part of the cycle here on the stage. And this is the thing, I think. Like, in my mind, this should come before the custom component. Because the only way for the custom component to exist is if you wrap inside of the stage, I think. This is always gonna be children of the stage, but maybe not. This is the thing that I have to clarify because I don't understand really well. Because if you call directly, they're just gonna return the type, which is the primitive. So what is happening is because under the hood, that's the issue, I think. Under the hood, so like this is not related to the life cycle of the stage. That's the problem. Because under the hood, what is gonna happen is React is just gonna, like, this is gonna return the type, and this creates the. But then how is it gonna render? Like, it has to be using the reconciler. It's the only way to know that this is gonna be a primitive in React, because this creates the primitive inside of these types injected here. So when React is reading the code, it has to know that this is a primitive. And that's gonna trigger the life cycles. And the life cycles are also different than the standard ones. The way you have to pass through this function. So I guess that's why it's confusing. Like, at what point is this being called, I think. And this is what's causing the problem, I think. Because the stage is on one cycle, which is the normal cycle, because it's extending the class, React component. And the other one is on this custom cycle that I don't know when it's going to be triggered. I think it has to be triggered through the stage. Like, so I think I have to test this first, but it's kind of annoying. So I need to think about a way to just do like a stupid component. I think it's a lot of work. Like, I need to create this pixi outside of the. I think I'll just copy this stuff and put it here. Let's see. It's gonna be here, here. And then I just copy this stuff. And I'm gonna remove the things from here. And then I'm gonna try to render this outside of the thing to see what happens. So that's fine. Let's see, 1, 2 components. Interesting. Let me think about. Object is not extensible. Let me think. Let me remove this. It's gonna break as well. So let me think. So it is calling the create on the elements, but then how and why is the question. Let me think. Elements. Maybe it's because of this invariant, but this should be just to check. Yeah, it just checks if the type exists or not. I don't think that this has anything to do with that. So the question is, why does it... I think it's because of the way that the React works, just using the create element here, but the question is why it uses this one. That's the thing. I think I'll be right back. think I'll spend more half an hour here. And I'll go grab something to eat. And probably watch videos, the React videos. But I think I'm on the right track here to solve this. It's probably what I'm thinking about. But I have to understand. I think what I'm gonna do is change the way that I'm importing this. I'm gonna import directly from the file itself to see if it changes anything. Source, then reconciler. No, it's not a reconciler, it's the elements from Tio's element. Tio's elements. It's still the same thing. Should I put the timer? Yeah. That's very interesting. So I think the explanation must be that it's using this. It uses this type somewhere, types injected. It has to be calling this. How is it possible that it calls this? That's the question. Like, how is it calling this function without me explicitly calling the function? Because the thing is, like, if it is related to the reconciler, then the reconciler has to be changing the rendering process of the whole application. But I also don't understand how that's happening if, like, I'm not importing at the top level. Like, it doesn't make sense to me. What makes more sense is that the reconciler is only used at the components that are below the stage level, because the stage is the thing that initializes the reconciler. So I don't understand how is it possible that this function is being called without me explicitly calling it. Because I get that in React is going to be create element. So like React is going to call its own create element when it sees this component here. But then why is it using that one? That's what doesn't make sense. So it must be something under the hood that is happening that makes it so that that function is called instead of the standard one from React. And I think if I comment this out, it's not gonna give me an error. So I'm pretty sure that is. Oh, it still gives me the error. Interesting. So what am I missing here? Yeah. Does it make sense? Okay, I'm pretty sure I'm not wrapping this file with the... Like, there's nothing related to React-pixi here. Neither here. So weird. Don't understand. Like, why? Just calling the function there is already triggering the thing. It doesn't make any sense. Mix it those elements. Trying to think, how can I... Like, it would be great if I could see the cycle, like step by step what is happening. Sure, there are tools out there to do that. I think I've seen some videos, people recommending some tools to debug the React, just see what happens on the components. But I'm not sure if I want to go through the effort, I think, of learning that stuff now, or using the tools now. I think it's better to just think how that's possible. React reconciler development. Here. You must be triggering the reconciler at some point. But how? Maybe it's because it's importing all the components. That's probably why. And then on the other components, it's doing that. This is also very interesting here. So this is adding event listeners to everything, I think. Maybe this is one of the things that is messing up there, is because it's overriding events from Pixi viewports based on this stuff here. So I'm trying to find the connection between this file and the reconciler. And maybe I should comment the whole entire file and then just leave the pixi component part. See if it changes. Think I'm gonna do that. Not sure if it's gonna work because of the other comments. That's annoying. How is this possible? Some other file. Oh, it's in index.js. Yeah, so that's why. Because when he imports there, imports everything here. Because it's importing the types here. And then here it's importing the reconciler. A pixi file. So maybe when he runs this, it creates the reconciler. That's probably what's going on. So where is the file? It's on the other one. The other file. And that's the issue. So how do I stop? Because I already comment. Oh, maybe it's because I'm importing here. Yeah, that's why. Okay, now it works. Oh, it's not gonna show anything. So let me try to instantiate this. Oh, this fails. It fails here, but it doesn't show anything now. Interesting. So let me console log this. And it's just a string. So I think it is what I was thinking about. It's like because of the is exporting everything there. When it runs the code to import this, it is gonna run the code for everything else, and then once it runs the code for everything else, it creates the reconciler based on the host configuration, and that's why it makes it so that it triggers the function. So I think any point of the application where I import anything that uses the React-pixi library is gonna do that. Like it's gonna run under the custom render reconciler, which is the React-pixi reconciler, and then it's gonna use this create function instead of the other ones. It's gonna use this one to create the elements instead of the other ones because of the reconciler. So I have to study this file here to understand how it's changing the thing. But yeah, now I think I understand much better. It's interesting that it has events here as well. So it is obviously related to the Pixi viewport events, because this is what is creating the custom rendering. So there's some conflict and some like lack of synchronicity, let's say, between this one and the other one. It is kind of weird though, because like the reason why I'm not sure is because like if it was the case that is a rendering thing, then why would they create a library like this where the Pixi component would be unmounted before the or after the app? Like it doesn't make a lot of sense. Because obviously, like it's only logical to think that you're always going to use the Pixi components inside of a stage. Like it's more likely that that's going to happen than the other way around. So it would make more sense in my mind that the custom Pixi component is always updated before the app. So the life cycle happens like first the app mounts, then the Pixi component mounts. Then first the Pixi component unmounts and then the app unmounts. So it's like the Pixi component is sandwiched between the app. That makes sense. It mounts after, but it's unmounted before. But I think that what's happening is the other way around. But maybe that's not the case. It's being mounted before and then unmounted after. No, unmounted before. Yeah, unmounted after and mounted before. Create instance is create element. This is the stuff probably that changes the thing. So let me think. So I think I can undo all this stuff because now I'm pretty sure that this is what's happening, so. So first exports everything here. Yeah, I still need to understand like how is the function triggered though. That's the problem. But how can I go about figuring that out? I guess I have to understand like how the reconciler works more. To see if what I'm thinking about makes sense. So what I'm thinking about now is that like the weird thing is that it exports everything here first, so it runs this code first before the reconciler. But maybe it doesn't matter because at the point you call the function, it's ran through this code. I think that's the case. Maybe the other thing that I could try is just comment this out and see what happens. Yeah. Okay, and I didn't comment, but maybe it's because I didn't uncomment here. Yeah. So let's see. Ah. There we go. Oh, let me think about it. Is it still running everything else? So how is that possible? Like I'm commenting out the reconciler and the other components are still being created, but then it fucks up here before. Let's see if I do this again. It's gonna change. Yeah, now, no, it doesn't work, so. I guess it's just because I changed the way that it was working there. Because of this thing here. So let me comment the reconciler again. It's probably gonna work still. Yeah, I don't understand. Let's see. It still fucks up the same place. So it can't be anything related to the reconciler. It doesn't matter. So I think I still need to understand at what point is the function being called when I do this pixi, custom pixi component. Why does it call that create element there if it's not calling the function anywhere? Oh, maybe it's this, could be this thing here. So let me try to comment this one out, see if it changes anything. now is fucks up. But maybe it's because of something else. It's just because of this. So maybe it's still gonna work. Yeah, it's still working. Oh, how is this possible? It must be because of React calls that thing, but if it's not changing the... Okay, just gonna return viewports. I guess I can console log there to see if the function is being called on. I forgot how I saw it the first time. This is interesting as well, as I wasn't getting this before. Render is currently rendering the same context provider. So it must be that the reconciler is somehow rendering, even though I'm commenting out there. Let's see, container tags graphics. Yeah. This one is calling this, but it's probably not related to the custom component. I just set in the events. And these are on NOS. So it must be the reconciler thing. Oh, maybe it's because of the stage. Yeah, but yeah, maybe it's because of the stage. Because on that file I'm creating the stage first. So let me comment this out. Yeah, now it's viewport, but it's not running that. It's not because I'm console logging there inside of the function. Here. So let me try to create the component. And now it fucks up here. So it is the reconciler that is running the create element function. And in that case it's running through the stage. So now I can uncomment there and see if it's gonna change anything. I think it's not gonna change, yeah. So it only changes when you run inside of the stage, as I was thinking. Because then, when you run the stage, component's gonna be initiated, so at first there it just creates the... It just returns the string and creates the type. And then when you run the reconciler, it's gonna get the component from the type, which is an object that has the functions, and then the reconciler is going to create the lifecycle based on the whatever you pass inside of the component. So I'm pretty confident now that this is what's happening. So now I'm gonna watch the videos about the reconciler again, then I'm gonna study the source code to understand how it works, and then try to figure out why the cycles are messed up. And it breaks the event listener on Pixi view parts. And how to fix the cycle. The rendering cycle. So that the Pixi works. Pixi view part works. Yeah, I'll be right back. Just gonna watch these videos here again. So I'll be right back.
Sophie. I used to work at Facebook and manage the React team, but then I abandoned them in January. Now I'm an engine manager at a tech startup called Humo, where we're trying to help people build work environments that are more fulfilling and empowering and inclusive. And you can find me as Sophie Bits just about anywhere on the internet. So today I want to go under the hood of React a little bit. Since you're here, I assume most of you use React, but I'm guessing you won't know most of the things I'm going to talk about in this talk, and hopefully you'll learn something. You probably read the title of the talk on the schedule, so you know where this is going, building a custom React renderer. But I want to start with some of the basics. So when you sit down and write down some of the different parts of React, you might end up with a list something like this. Let's see, you have the built-in components. Those are like div and span and image, things like that. You have function components. You have class components. You have props and state and effects and life cycles, key and ref and context. You might know React.lazy and error boundaries, and then the new stuff, which is concurrent mode and suspense. And you've probably also heard of React Native. And in React Native, everything on this list behaves exactly the same, except for this first line, these built-in components. Instead, on React Native, you have components like view and text and image, things like that. And they take a different set of props and event handlers. And so the way React is implemented, the code for everything in this bottom list is completely shared. And on the React team, we call the code that implements this the reconciler. And it's set up to plug into these different platforms like React DOM, React Native, which are officially maintained by the React and React Native teams of Facebook. And some people in the community have also connected React to other platforms like 2D drawing libraries and 3D graphics libraries, and even rendering for command line applications that run in a terminal. And so we call each of these platforms a host environment. That's because it's conceptually hosting your copy of React and providing the base level primitives that React runs on top of. And I wrote built-in components here, but usually on the React team are, we say built-in components colloquially, but our formal name for these is host components because they come from the host environment. And so this reconciler, this bottom list, is part of the code of React DOM and React Native. It's part of what you're getting when you install each one of them, but it's also available as its own package on NPM called React Reconciler. It's not nearly as stable as the main APIs, and it doesn't have a ton of documentation, but you can build your own renderer using that package, and that's what I'm going to show you how to do today. The reconciler package has two different modes, depending on what kind of host environment you're trying to integrate with. The first one is called mutation mode. You use it whenever you're integrating with an environment where you have views that are mutable in some way. This one will probably be a little more intuitive to most of you. And so usually what this looks like is the host environment, you have some sort of create view call, maybe this returns a view. And then when you want to change the appearance, you mutate this view somehow. So maybe you call it update view, which takes some new props. So maybe you're setting the color to red. And that will mutate this view in place. And I'm using sort of a generic API here. If you're thinking about an actual DOM API, this would look more like document.create create element. This will return a div. And then to update the color, you might do div.style.color equals red, something like that. And so React DOM is built using this mutation mode because mutation is how the DOM itself works. The other mode is called persistent mode. And I'm not going to talk too much about this today, but I do want to mention it. It's used for if your target is an environment where the API treats the tree of views as persistent immutable objects, where instead of mutating a view in place, you create a new version of it each time you want to create it. And so that looks something more like create view, and then instead of update view and changing it in place, maybe you call it clone view, where again, you pass it some new props, but instead of changing this view, this returns a new view, like a new version of that same view, and then you need to update the parents to point to that new copy. The next generation version of React Native that the team's been working on for a while uses this mode because it's more efficient in several cases, especially with concurrent mode. And in React Native, we have complete control over the environment, so we can make it work like this. So the one I'm really going to dig into today, though, is mutation mode. Whenever React does a render or a re-render, including for a state update, it calls into all of the relevant components in the application. It does a sort of def, and then it comes up with basically a list of commands for what needs to happen in the host environment. Commands like update view x to view red, or it might say create a new view, or it might say add that view you just created as a child of view y, something like that. And so our job in bridging React to this host environment is to implement how each of these commands works. I suspect that many of you are familiar with the basic DOM APIs, like document create element and div.style.color. So to make this a little bit easier to follow, what I'm going to build today is a simple version of React DOM. This might not be quite as exciting as building against the Flash AD platform, but you can take what I'm going to show you here and apply it to any platform, not just the DOM. So let's get started. My base here is going to be a create React app, which most of you may be familiar with. And if I open index.js, you can see that it's using the real version of React DOM, importing from that React DOM package. And what I'm going to do is just take out React DOM and replace it with our own version. So I'm going to make a new file. I'm going to call it React DOM mini. And then I'm going to import that file. And then instead of React.DOM.render, I'm going to call React DOM mini.render. And it crashes because I haven't actually implemented anything in this file yet. But in my render implementation here, this React DOM mini.js, I'm going to start by importing the reconciler module from NPM. So this is import React reconciler from the React reconciler package, which I installed in my project. That's really the only change I made from a plain new installation of Create React app. And so this is the package I mentioned that has all of the guts of React that are shared across different platforms. And so the basic structure here is I'm going to instantiate React reconciler. And this takes a sort of config object, which is configuration for how to talk to the host environment, or we can call this the host config. And this returns a reconciler. And then the API for this reconciler object is slightly different than the top-level API of React DOM. So in order to make the .render method available that we're calling here in the index file, I need to define an object, which I'll just give one method. And render should take two arguments. The first one is what we're rendering, and the second one is the container we're putting in. So this is what to render, and then the diff we're going to put it in. I'm going to export this. When the render method is called, we're going to want to call into the reconciler somehow, so that this thing we want to render actually gets passed to React. And so if I reload now, I'll see a white screen because my render method doesn't do anything yet. And in this host config, there are actually a whole bunch of methods that you need to implement that are working render. And so I'm going to paste in a little shell here with just some stubs for methods. You can see that I'm starting with supports mutation, :true. That means I'm going to use that mutation mode I talked about. And I have a bunch of methods here where all the implementations are empty, but that'll save me a little time typing later. And don't worry too much about reading all the names. I'll tell you about the important ones as we fill them in. I'm also going to fill in this render method with a couple lines where the reconciler has its own notion of a container. So I'm going to first do reconciler.createContainer, pass this div a couple false arguments, which I believe are for concurrent mode and server-side hydration, neither of which we're using today. It says return container, and I call reconcile.date container with what to render and a reference to that container, and a couple of nulls. And I don't need to return anything. That's all I need to do. So the first method in this host config that I'm going to implement is called create instance. This gets called whenever there's a new host component that we want to put on screen. It has a bunch of different arguments, but the ones we really care about are type and props right here. So I'm going to start by just logging type and props. And if you look at the DevTools here on the right side, you can see that type is just going to be a string that is the HTML tag of the element, and then props is going to be a props object for what is being passed to that element. And I want you to notice that already all we have to worry about dealing with is these low-level host components. Even though there's this app component that we're rendering, you don't actually see the app component in these logs here because React is taking care of it before this method even gets called. And so what we want to do, well, to create a new node in the DOM, we call document.createElement. I'm going to pass it the type, which is again the tag name that we're using. Store that in a variable called EL. And then I want to deal with the props as well. I'm going to start with this class name. So if props.className is present, I'm going to do l.className equals props.className. And if props.source, I'm also going to do source because there's an image and it won't look right if we don't have the source. We'll do that the same way. And then we're going to return a reference to this element. It's worth noting that React itself is not designed to be tied to the DOM, so it doesn't actually have any idea what a DOM element is or how to interact with it. So you might be wondering why we even need to return it here from create instance. The answer is that React reconciler isn't going to call any methods or set any properties on this object, but what it is going to do is pass it back to us in some of these other methods so that we can manipulate it later. So React doesn't actually care at all what the shape of this return value is. So if I wanted to return maybe some other data with it, I could return an object that has some other data here. And React doesn't care. But for our purposes, it will work for me to just return the element. I also didn't tell you yet about a second type of host component that we also need to implement, and that's a text component, or more specifically a host text component. You know when you write some code like this where you say if, and it says click here, you have a button. You can see two components already. You have the div component and the button component, but there's actually a third component here, which is click here text. So whenever you have a string or a number in your component hierarchy, React is going to create one of these text instances. And the implementation here is pretty simple. We get to just call document.create text node and return that. The browser here is going to return to us a DOM text node, which if you're not familiar with DOM, is pretty similar to a DOM element. It's just a different type of DOM node that can live in a DOM tree. And when the browser renders it, you can see some text. This is also how any type of text in a page works. Like when your browser is just parsing some HTML, if it sees a piece of text, it creates one of these DOM text nodes. So we're just doing the same thing. So now we're creating all of these instances. We don't see any of them yet. And the reason for that is that we're not attaching the node anywhere. You need to add an element to some parent in order for it to actually show up in the DOM. And in fact, we actually already be calling these next three methods for append child. We're just not doing anything in them. There are these three different methods: append child, container, append child, append initial child, and they're called in slightly different situations. The differences aren't that interesting right now, so we actually want to do the same thing in every single one of them. This child value here is going to be one of the instances that was returned from either create instance or create text instance. So it's going to be either a DOM element or a DOM node. And container here is also going to be a DOM element. And so I can call the DOM's append child API that's built into browsers. So I'm going to call container.append child. I'm going to do the same thing here. So now each time React wants to add a new element to the hierarchy, it'll call one of these three methods, which will end up calling the DOM's append child API. And so if I save, hopefully, you can see it works. And so you can see we've only written about like 10 lines of actual code, but already we have something on the screen. That's pretty cool, right? I also, before we get into updates, I want to fill in a couple more props here. I did class name and source, but there's actually 6 different props that are used here, and that's why like this learn React thing that is supposed to be a link is not underlined, and I can't click it. And so let me fill those in. Those are alt, class name, href, rel, source, and target are the ones that are used in this app. And so for each of those, I'm going to say if props has that key, then just copy it to the element. I don't need that anymore. And you can see now I have a learn React link, which opens React update. Cool. So we don't handle any state updates yet, which I guess kind of defeats the purpose of using React. So the spinning logo, by the way, is done completely in CSS. There's no JS updates, so that's why that works. But let's change that and add some state. So here's our app component. And for this demo, I'm going to make it so that you can, when we click here, it'll toggle whether the logo is visible. So I'm going to add a state variable, let show logo, and set show logo. React.useState, and that's going to default to true. And then if show logo is set, I'm going to show the logo. Otherwise, I won't. And then I want an on-click handler. So on-click, I want to call set show logo. And I'm going to set that to whatever the opposite of what it was before is. And I made a typo. No, I'm missing a brace here. Here I'm using the functional update form of set state, so I got the old value here, and then I'm supposed to return the new value. And if I reload and try to click, nothing happens. And the reason for that is we didn't ever say what on-click means. The only props we're handling are these ones that we wrote down in create instance. Remember, React doesn't know anything about any DOM-specific properties. It doesn't know what a click is. And so if we want on-click to do something, we need to handle that ourselves. So if I log the props.onClick property, then you'll see on the right side that it is that function that we just set up. And so the logic to actually call this when I click is pretty short. I'm going to say if props.onClick is present, then I'm going to call add event listener on the element, give a click event, and pass props.onClick as the function. And so if I did that right, now when I click on the page, it's going to call my function, which is supposed to hide the logo. Do you think it'll work? So if I click, then I get an error. And I think the event listener actually did. We can verify this by adding an alert here. I'm just going to say alert hi. And if I click, I do get that alert. So the event listener is working. It's actually the re-rendering that's throwing an error. And so the reason it's crashing now is that I didn't actually implement the methods that are used for removing things from the DOM, which is these remove child methods. And the implementation here is also going to just be one line. I can call the built-in browser remove child method on the container element or on the parent element. While I'm at it, I'm also going to fill in these implementations for insert before, which is used when we're adding an element in the middle of the list instead of at the end of it. And luckily, we can just also use the built-in DOM API insert before, because it has basically the same API. So child is the same, and then before is another node that you want to insert it right next to. And so I do this, I call. And so now, when I click, does the logo actually disappear? It does. And when I click again, it comes back. So you can see that in our renderer, we didn't have to write any logic specific to state updates or how they're handled or knowing when to re-render, but we were able to use state within our component. Again, that's because React State works exactly the same on every platform, and so it's implemented inside this shared React reconciler module. And now we can handle components being added and removed. The final big piece I'm missing is updating properties of components that are already on the screen. Let me make it so this text here on the right side is the background color that just changes over time. So I'm going to have a color variable. I'll start with red. I'm going to add an effect. In this effect, I'm going to have a list of colors. I'm going to cycle between red and green and blue. I'm going to have a counter, and I'm going to call set interval. So every 1 second, I will increment I and call set color with the next item in the list. So that's I'm on 3. We'll loop around. This will return an interval, and then to clean up, I'm going to return clear interval. And let me set this as the background color of this paragraph tag here. Now, up to this point, I've been matching the APIs that React DOM itself uses, and so this component works exactly the same if you were running under React DOM. But I want to remind you that we're actually building our own environment here, and so we can kind of do whatever we want. Let's say I don't like the CSS inline style API. I want to go back to the days of HTML3 where we just put like a BG color attribute on any element. And so I'm going to do that. I'm going to write BG color equals color here. And then to make this work, I'm going to have to handle it in create instance. Again, I'm going to say if props.bg color. And here I do need to use the style API that browsers have. I'm just going to set it to props.bg color. And that works. So if you tried to use this prop in React DOM, it wouldn't work, but we make the rules here, so the background value does work. The effect I wrote is probably working, but the color isn't changing, and let's make that happen now. When React does any state update, it calls all of the components and tries to figure out what changed between the old and new trees. And it does all of this before actually modifying any of the actual host components. These render calls and the diffing happen in what we call the render phase, and then once we prepare the whole tree, that's when we go to the commit phase, which is when we actually change things in the host environment and mutate the DOM. So to make updates work, we have to implement 2 more methods, prepare update and commit update here. And they're divided according to these 2 phases. Prepare update is called in the render phase, commit update in the commit phase. And so it gets a whole bunch of arguments here, including the old and new props, and it's supposed to return what we call an update payload, which is basically just a diff between the old and new props. So I'm going to make a payload variable, and I'm feeling a little lazy, so I'm only going to compare the BG color props. So I'm just going to say if old props.bg color is not equal to new props.bg color, then I'm going to set the payload. And this can really be whatever we want. React, again, doesn't really care what this is. It's just going to get passed to our next function. So I'm going to say new BG color is going to be new props.bg color. I'm going to return that payload. And then in commit update, we get the component instance, which again is the DOM element itself, and the update payload that we just returned from prepare update. So here, what we need to do is we need to say if update payload has a new BG color property, and then I'm going to set style.background color equals update payload.new BG color. And I think that should do it. So you'll notice that just like for state, we didn't have to do anything special for the effect to work. React takes care of all that. It just calls us when it's like, oh, now it's time to change this host component and what it looks like. And so now we have a renderer that can render this page, do some basic event handlers, and handle changes in the component tree, both adding and removing components, as well as updating components that are already on screen. And I think that covers the main things that we expect React to do. And this file is still only about 100 lines. And that's all you need in order to write a basic interface with a new host environment. So I feel pretty good about this. The real React DOM implementation implements these exact same methods. This is how the real one works. It probably wouldn't surprise you, though, to hear that the real React DOM is quite a bit more than 100 lines. And at this point, you might be wondering what the real one does that I didn't build here. I don't have an exhaustive list, but I wrote down a few of the major differences. In this toy version, we're only handling a few properties on initial render and on for updates. We don't have any special support for form controls. There's actually quite a bit of logic you need to handle controlled and uncontrolled components. We didn't build anything in for refs, and so although you can, so if you try to take a ref to one of these host components, instead of getting the DOM node back like you do in React DOM, you just don't have access to it, and there's no way to actually get the associated DOM node in this render we built. There's a lot of attribute and event normalization for cross-browser compatibility that I left out, and we don't support SVG. Event bubbling through portals is another one. I didn't actually test portals at all, so I have no idea if they work. And probably a lot of other edge cases I forgot, but I think these are the biggest differences. And that's all I have for you today. I don't know if this talk is super practical for most of you. I imagine it's rare you'll find the occasion to build your own React renderer from scratch, but I hope you found this fun, and I hope you learned a little more about how React works, and more than you knew before. Thank you.
This is nowhere. What's up? So in my last video about React India, a great commenter, subscriber, Shivam, mentioned he was struggling to understand React Fiber. By the way, if you want to watch that React India video, I'll put a link up there. But Shivam mentioned, hey, I'm trying to understand React Fiber, and I was like, bro, you're a subscriber, I care about you, I care about this channel. I'll just make a video that breaks it down. And out of that comes this video and probably the next one. What we'll do is a 2-part series on Fiber. This one more like theoretical with diagrams, why the stack reconciler didn't work, what reconciliation even is. And then the next one practical, like we'll actually look at the React DOM source code and step through the functions. If that's interesting for you, feel free to subscribe and hit the bell so you don't miss it. Okay. And with that, let's just begin. Let's talk about reconciliation in React. What is that? What does reconciliation mean? I think reconciliation is probably the biggest part of React, like the biggest value proposition of React. What reconciliation is reconciling your description of what you want your user interface to look like and behave like with some host environment. In the case of React Web, a browser. In the case of React Native, a mobile device. And in the case of React Inc., like some type of terminal. But this is what reconciliation is. Like you write your JSX files, you describe, okay, I want this nested main side nav, user profile, whatever. Like you define your tree of elements, and React will take your description in JSX and reconcile it with a host environment. That reconciliation just means put this stuff on the screen this way and behave to events like this. That's what reconciliation is. Or before React 16, we had what is called the stack reconciler, a stack-based reconciler. It's where it used a stack data structure for reconciliation. And then after React 16, you had after React 15 from React 16, you had the Fiber reconciler. So in this video, we'll talk about what the stack reconciler is, why it didn't quite work, what Fiber is, and how it works. Okay. With that, let's get into it with some diagrams. I'm going to be using TL Draw for diagrams, and we're going to be drawing a stack. There you go, that's a stack. This is a stack. A stack is a last in, first out, or LIFO data structure. And what that means is if you have like work to be done on the stack, you just stack it up just like this. And the thing that's the last in is the thing that's the first out. The last in is the first out. That's LIFO. Things are popped off the stack or pushed on to the stack, pop, push, and that's how you have it. The problem with stack-based data structure is that it is sequential and hard to do like parallel or concurrent stuff with, which is a problem for UI or user interface engineering because user if input events have an inherent like sense of priority. What I mean by that is if you have like a text input field, like an email address field, like if they start typing, you need to respond to that keystroke immediately. Can you imagine someone types like K and then like it comes like a second later in the screen? That's going to be nasty. That's a high priority update. Meanwhile, like if you receive some notification from somewhere and you're not even expecting, if that shows up like a second later on the screen, nobody cares unless it's like stock market stuff. But mostly that's a lower priority update, right? So this priority is inherent with UI user interfaces. And so the stack data structure wouldn't be nice because if you have like high prior work here and some low prior work here, it would have to do this, 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 and this before it can come here. And if the low prior work is just some animation or something that takes time, your user experience is pretty much screwed. That's quite why the stack reconciler didn't work. And also, the stack reconciler did everything like in real time, like it made updates just on the screen. It would have been nicer if one, the stack reconciler was interruptible and had a sense of priority, and two, if it kind of did work off screen and only put stuff on screen when it was ready. Along this line of thinking came the fiber reconciler, which is both those things. It has a sense of priority, and it's able to bail out halfway through some update, do a higher priority update off screen, and then put that on screen. To understand this, let's actually draw a diagram that kind of represents the fiber reconciler. To do that, we'll just create like a tree of elements. We have a div. The div has a child that's like let's say a h1. H1 has a sibling span. The span has a sibling button. Let's give these a lot more space to breathe. I think that'll be essential for what we're trying to do. And we'll add, what is the shortcut for things? T. Nice. We'll add hello world as a child to h1. Again, more space. We'll add count. Well, let's build a counter. So count, that's one child, and then like the interpolated value, that's the second child. And then we'll add like a child to the button, that's plus. This is a counter that can only go up. I wish that's my salary or my income from YouTube. Anyway, jokes aside, so this is a tree of elements, and let's connect them. So it's a child of that, that's a child of that. Siblings, right? Children, two of them this time. Look at that, beautiful. Sibling again, child. So now we've got this tree, okay? And you can say this is a tree of fiber nodes, okay? Let's call this tree, let's put it in a big box, and call this the current tree, current, okay? And let's just, as a description, let's say always in the browser, okay? Or rather in the browser right now, okay? There you go. So that is representative of a tree of fiber nodes, okay? What's so cool about this? Well, fiber does work, like work required to update the user interface in two phases. One is the render phase and one is the commit phase. It makes updates in the render phase and it does this off the screen in memory. And then when the rendered work looks good, it commits it in the commit phase to the screen, puts it on the browser. To do this two-phase approach, fiber needs to maintain two trees, a current tree like we have here, and really a copy of the current tree called the alternate, or you just saw my notification, whatever. The alternate tree or work in progress tree, let's call it like this, alternate or work in progress. Great. And this is not in the browser, this is detached from the browser. Okay, so it maintains these two trees to render and commit. Then it does the rendering work off the screen in the work in progress tree, and when it looks good, commits it. I want to talk to you about how exactly it does that. Let's imagine a user interface update. Okay, let's imagine somebody comes here and clicks this. Okay, so in our initial state, so to speak, count is 0. And then in the next, how does it get to this? It works with functions calling other functions in both the render phase and the commit phase. Let's model that. So to kick off the render phase, there's what is called a work loop. So work loop, and this is kind of like a game engine. As long as there's work to do in a loop. Okay, the work loop is literally that. Like the code looks like while work to be done true, do work. Okay, what is work? Work starts with a function called begin work. So let's write that down. I would say begin work. Begin work takes as arguments the current fiber node, the work in progress fiber node, and render lanes. Render lanes are important for scheduling, but that's out of scope for this video. We may do another video about that. But I want you to pay attention to the current fiber node and the work in progress fiber node. A current fiber node is something that's in the browser right now. We do not mutate this. We just read from it to compare what is on the screen with what's about to be on the screen. What's about to be on the screen is the work in progress. So these two are important. This we never change. This we change. And go from there. So when there's work to be done, like you click this, right? There's now officially work to be done. So we call begin work. Where do we call it? What do we pass in for arguments? We pass in the top level. This is like the app component, right? This is like kind of like your this thing. Okay. So we pass in this and we do work on that. And we pass in this as the second argument. And what we do is we do work on them. What work happens in begin work? It marks update flags. It'll like compare next props with previous props. Did anything change? Yes. Then it sets a flag. Stuff changed. It sets a bunch of flags that mark this component as needs to update. That's what it does. When it's finished, it recursively calls begin work on the next thing. It steps down in the tree. So you begin work on the top. It sets a bunch of flags, then calls begin work on div, passing in these two. So the current node and the work in progress. Okay, cool. Any updates here? Okay, good. Walk down one more. Okay, now we're in H1. Great. Any updates? Mark flags. Begin work on the child. Now when we reach the bottom, we can't really go any deeper because we're at the bottom. It sets a bunch of flags, and then it will either go to the siblings, but it will, before going to the siblings, we'll call a function called complete work because the begin work needs to complete work. So we'll model that here. It actually takes has the same signature, so it takes the same arguments, and it calls complete work. So we get to the bottom, we call complete work. What does complete work do? We already know begin work sets a bunch of flags and walks down. Complete work constructs an HTML, like a tree of elements, an HTML element tree, not in the browser what you can see, but in memory. So it constructs this tree, attaches nodes, and then moves either up or to the side, and basically walks back up. So begin work walks down, setting flags. Complete work walks back up, composing a work in progress like element tree. How can you create a tree of HTML elements not detached to the browser? I'll show you. So if we open the console here, console, I can do something like const div, create element div, const span, const span is create element span, and then I can like div dot append child span, and I can like console log the div, and I have look, I have a tree. This is nowhere in the browser. It's just in memory. If I want to put it in the browser, I would do document dot append child div, and now it's part of the document, right? I won't do that because it'll mess up TL, but that's the commit phase. Document dot append child is kind of, you can think of it as a commit, and all of the work before that is just complete work. So it constructs this tree, attaching things, and it gets to the top. When it gets to the top, the render phase is finished, and we shift to the commit phase. What does the commit phase do? Well, when we're finished with complete work, then the alternate tree is the latest and best state. So we need to commit this tree to the browser, to the host environment. To do that, we need to look at the fiber root node. The fiber root node is a hidden real root of your fiber tree. The root is not this. The root is this. And when your app starts, like before any updates are made, it has a pointer. It points to the current tree like this. But then after complete work finishes on the work in progress tree, the commit phase will basically take this pointer and point here. And then count one, the latest state is in the browser, and the work loop is done. This happens every time there's work to be done. The cool thing about this is because a lot of this work rendering happens off the screen. If a high priority update comes in to interrupt that, it can't, because you haven't seen anything change. So you can just bin low priority work, you can get rid of it, bail out, do the high priority work, commit it, and then go back to low priority work. It's interruptible because it's not a stack and it's also not on the screen. There's like a draft UI that it's always working with in the background. That at a high level is how the fiber reconciler works, why the stack reconciler didn't, and what reconciliation even is. I hope that's helpful. If it is, let me know in the comments, or even if it's not, let me know in the comments so we can improve. What did you think? Is this good? Also at me on Twitter. Next time we're going to be looking at this. So last time we talked about React Fiber. We looked at it from a high level. We looked at the stack reconciler versus the fiber reconciler. We looked at what reconciliation even is, and we drew some diagrams connecting things together. If you missed that video, stop, go watch it right now. I'll put a link up there. It's important you watch that because we're expanding on that, and I'm going to assume you watch that, okay? So there are many things you don't know, just go with it. Again, the link is up there and under the like button. Today, we're getting practical. We will literally look at the source code of React DOM, and we'll use a time-traveling browser to do it. It's going to be nuts. Let's get into it. Okay, so first of all, listen, I know this is a React video, but I'm allowed to wear whatever I want, okay? Just before y'all at me. But here, we're going to open replay. And what we're going to do is literally use a React app that we built in the last video and time travel through it, looking at what called what when, and looking at the call order of React Fiber reconciliation functions, specifically the work loop, begin work, complete work, commit root, to get a better understanding. I should say as well, you don't need to know any of this to use React effectively. This is just for curious people, like me and probably you. Okay, with that, let's get into replay. So this is it. This is the time travel browser. I'm going to hit record, and now I'm going to click 1, 2, 3. 1, 2, 3. I'm going to click 6 times and stop recording. Now it's going to ask me to name my replay. I call it Fiber, and it will upload. The upload does take a little bit of time. The team I think is working on making this faster, but when it finishes, we're going to see time travel. Like it's real. The upload is still happening, but I expect any second now, magic's going to happen. What would be really cool is a progress bar. Progress bars are awesome. They give you a sense of like how long something's going to take. Anyway, it's done. And what we see here is the replay. Now I want to draw your attention to this seek bar, okay? Like if I click this, and it's going to start playing, it looks like a video. But here's the deal, it's not a video. It's like actual code executing in a paused, time-travel-y way. This is nuts, and if I click on the info, I actually see all the click events, and I can jump to different click events, and I can travel back in time, and pretty wild. There's also dev tools where I can like straight up look at the thing that called the click, and I can leave a print statement, and I can say, click happened here, and do this. And if I play, I see in the console where the clicks happen. I can literally like fast forward to certain clicks, I can rewind to other clicks. It's pretty, what's the guy from Back to the Future? Marty McFly? Anyway, so yes, but here's the thing about replay. It allows you to time travel through node modules. So we're literally gonna look at the source code of React DOM and travel through time as we understand it, okay? So to do that, I'm gonna go here to the sources, go to node modules, React DOM, CJS, React DOM.development.js. I'm gonna collapse this sidebar because we don't need it. And look, we have syntax highlighting and everything. So now, if you saw the last video, we talked about some functions. We talked about how the fiber reconciler starts with a work loop sync. While there's work to do work. Okay, let's go find that. So work loop sync, boom. Let's look at what it actually does though. Let's go to its definition here. Look at this, while work in progress is not null, that means while there's work to do. Do it. Declarative programming. Okay, but what does perform unit of work do? Perform unit of work takes a unit of work, and then if we're in profile mode or for non-profile mode, we assign next to the return of begin work $1, which, as we saw in the last video, takes a current fiber, a unit of work, and subtree render lanes. What is begin work $1? Let's go find it. So this thing is basically how React suspense works. Okay, so we have a work in progress copy in dev, and we have massive try catch. Try begin work, catch with suspense. We're not going to look at that, but in the try we have a call to begin work. Let's look at what begin work does. Now, if you remember the last video, again, link under the like button. Begin work is a function in reconciliation that marks updates, that sets flags on a given fiber and then moves down. Sets flags on children, moves down, keeps going down the tree, setting update flags until there's no more down to go. Okay, once that's done, we start getting into complete work territory and coming back up. We'll talk about that. But for now, let's focus on begin work. Let's add a print statement straight away. We'll do begin work called on, and we'll log the work in progress argument. We'll play that. And what we can see here is begin work called on. This is a fiber, by the way. A fiber is a large JavaScript object with a lot of things, and it just contains a lot of state to tell React how to make updates. So that's a fiber. I want you to pay attention to two things. One, the tag on the fiber. So this number here, and 2, the state node. The state node is the actual like stateful work in progress node in this case, okay? But now let's look at what's happening in begin work. If current is not equal to null, that means if there is something, if there is a current node in the browser, this is going to be an update effect to an existing element. It's not actually going to be an effect, it's going to just mark that an update effect needs to happen. We compare some props, and we set a flag did receive update true. We just continue down here setting this did receive update or not, but on what do we set the flag? Or rather, how do we continue begin works flag setting? If we scroll down, we just see a massive switch case on the tag. We mark different types of components, different types of fibers differently. In case of the indeterminate component, this function happens. In the case of lazy component, we don't have any of those in our tree. By the way, the tree that we built last time is here. It's just a div h1 span button. And as we can see here in the console, we call begin work on div h1 span, spans children button. We'll follow the whole loop shortly. Let's just look at what begin work does. In the case of function components, update them this way. And we just go through this whole thing, basically saying this needs to update or this doesn't need to update. And we keep going down. Next up is complete work. In fact, let's look at the completion of this function. After the big switch case, we throw an error saying, yeah, I don't know what tag you're talking about. So now let's look at complete work. Complete work. It takes the same arguments. We covered this in the last video. And for all of these kinds, it's also, by the way, a massive switch case. For all of these kinds of fibers, it's called bubble properties, which is a concern of render lanes, which we will not cover in this video. But for class components, it does this. For host routes, it does that. I want to look at what complete work does for like DOM elements, because I think that's going to be useful for your curiosity. To recap, begin work sets update flags on the way down. Complete work builds a DOM tree in a detached state and goes up. Okay, so it builds it literally like the next state, the next tree of elements, not in the browser yet. And then the commit phase puts it in the browser. We covered this in the last video. Let's look at how complete work does that. The host route is exactly what it sounds like. It's the route where you mount your React component. I want to look at the update for a host component. A host component is, for all intents and purposes, your DOM components. How does it update or add those? Let's look. So I want to draw your attention to specifically the how complete work builds the tree, how it appends children, because I think that's really interesting. So if we come to the hydration stuff, this code here is for elements that don't yet exist that complete work will add. Create instance is literally document.create element, more or less. Append all children will document.append child. So like we looked at in the last video, we're literally building a tree. We're creating documents and appending documents. We're creating elements and appending children to them and building an entire tree off the browser. Let's add and appending children to them and building an entire tree off the browser. Let's add a console log and see this in action. So we'll do complete work called on work in progress. So now if I save that, here's where it gets interesting. We have begin work going down, complete work coming up, and let's cross-reference this with our tree here. So notice this is after we click the button. Begin work is called on the div. Okay, that's done. It's marked for updates or not, and then it goes down to h1. Begin work called on h1. H1 has no children, so complete work is called on h1. Then begin work is called on span, the sibling. Span does have children. It has this and it has this. So begin work is called on span. It goes down, and this doesn't have any children, so complete work is called on this. Begin work is then called on the interpolated value, and complete work is called on the interpolated value. Then complete work is called on span, and then we go to button. Button again doesn't have children except the text node, so which is a value, and then we just call complete work on button. Then we call complete work on div. Then we call complete work on the app, and then we call complete work on the fiber root node. So you can kind of see the flow going begin down, complete up. That is the entire render phase. If you got this, congratulations. Leave a comment. Tell me how happy you are if you are. Let's talk about the commit phase. To do that, we'll search for commit root impl. That's the function that does it. And what we'll do is we'll just add a little print statement here, and we'll say commit root called. Maybe log the root just for fun, and we'll save that. So we have the begin work and commit complete work done. We talked about it. At the very end, after you complete work on the fiber root node, we commit root on the fiber root node here. So commit root called, and then we click the button again, and the cycle repeats and repeats and repeats every single time. I think we are logging button click. Yeah, so click happened here, and this is the final click. Begin work on div, and it just completes work all the way up and commits root. That, my friends, is fiber reconciliation in action in a time traveling way. Thanks to replay. Was that understandable? You have questions, comments? Let me know what you think. Leave a comment or at me on Twitter. But for now, that's been it for the Fiber Reconciler series. Hope you've enjoyed it.
think one thing that I'm gonna try before I explore this stuff is just change the name there of the key. Let's put some music. So instead of putting interaction, put event here. Or events. I think this is, I don't know what's the point of this. And it's just setting the resolution.
points out that things like positions and velocities are not very precisely defined.
Like, I don't understand what this is. In my mind, it's supposed to be renderer. Like this thing here. I don't know, like, how can you call it if it is a string? It doesn't make sense. The problem is that I can't console log inside of here because it's a library, so it's not going to show anything. Or maybe when it's running through this function, it transforms into something else. And I guess I can console log inside of here. I don't understand what this does though. That's the issue. I guess it changes the events. And so this is the same stuff that the other file had. So as the beginning of the file was just the React compiler stuff. You have to see how the reconciler is creating. It's using the create element function to create the custom components. Maybe it's not related to the rendering cycle, otherwise it would console log there, I think, when it triggers. So maybe something else that I'm missing. don't think it's gonna change anything, but I'm gonna add the key to this stage. But I think it's not gonna change anything. It's really weird because it doesn't console log anything there, so I don't understand why it's not. It should be a render, I think, problem. But then why doesn't it console log? This is supposed to mount again the app. The app is initialized on the component in mount. But then it's not on mounting, I think, with the event. So it only mounts when it's loading the page, and twice because of the use effect. But then after that, I think it doesn't mount. And at the time that it mounts, the component should have the app instance. So what is happening once the event is triggered? Why can't it access the parent? Trying to think how can I capture anything about the cycle based on the when it calls this function. It's like it's clearly working at some times. I think it must be because of the cycle, the rendering cycle. But then how do I know like what part of the cycle is this messing up? And why does the why does this cause the thing to re-render? And shouldn't be calling this or showing up this thing here? Let's put the type because it's easier to see. And there's 4 graphics, then 2 containers, then the viewports, and then again. They should be showing more after, if he was using the create element. So it should be triggering a re-render. I guess I can console log here as well. And she's figuring out at what part. So it must be something else then. I think it's no in the beginning. That's why. Maybe we can change here to initialize everything on the did update and see what happens, or did mount. No, but then, like, what's... Because the problem is how I'm gonna... like, access the instance if I don't do it with the create. That's the issue. I guess let me try something else as well, which is to put a variable there to see if I'm getting the sequence correctly. What the fuck? That's because I have to put on the... There's probably a count here on the time. Let's do it like this, whatever. I just wanna increase the counter and see when it's happening on this function here. I forgot how to access non-local variables. Trying to think about what is the easiest way to just pass the counter. Let me try to see if it's gonna let me. Just do it like this. So it's 0 and then 1. Well, that's a weird thing Because like if it's not re-rendering, then why does it go back to being null? That's what I don't understand. Like it must be triggering the rendering cycle, but then why is not console logging there? It doesn't make any sense. It should be console logging here. A bit, maybe it's because this is just triggered on the create when it's creating mounting the element. So it's just triggering updates, but it's not unmounting and mounting again. I think that might be the case. But then it should console log this one, I think. Another thing you can do is just console log here to see. Yes, unmounting only once, which is in the first time. So it creates a mount and then creates again. And it's not unmounting, so it's not creating. But like it should be updating, I think. Render. Yes, I think it's just on the beginning. I think this happens twice for each thing as well. And 3. It only updates twice. Maybe that's the problem though. Because it mounts once. Yeah, but then that doesn't make sense. Because it wouldn't be the first one that would be no then. It would be the last one. So I think the issue is probably because the component doesn't exist on the first time, and then it does. So like on the initial stage there. It's on the when it creates here. It doesn't exist. But I'm pretty sure that I console logged this as well and it was the correct thing. Yeah, so it creates once. And when it creates, it should have, because this is showing that it does. Maybe if I put inside of the thing. Let me think about it. It's gonna be twice again. So weird. Like the weird part to me is that, like, if the event is triggering a re-render, it should console log at any point in the spaces that I console log. But it's clearly not console logging. So, like, I don't understand. If it is not triggering a re-render, and if the event exists when it is created, then how is it possible that it's no at some point? Doesn't make sense. The only explanation is that, like, at the moment that it creates, it exists, but then the event triggers some re-render or something, and then it stops existing because it was unmounted. But if the parts are not being console logged, then... But maybe it could be that this is the problem, that it should be re-rendering, but it's not. That could be the issue. But then, like, it doesn't make sense, because then it wouldn't show these elements here. That's the thing. It would just show no, and then it wouldn't work. And it clearly exists on the moment that it's created, so... Like when it creates the event listener there, here. I'm just gonna remove this. When it creates the event listener, it has the... Otherwise, it wouldn't be able to create the event listener in the first place. Yeah, but when I remove the thing, also fucks up. When I remove the configuration here. So the weird thing is that why is not console logging on the lifecycle? Maybe it's because I'm console logging on this stage. And the stage itself is not re-rendering, but the component is. That might be the problem. Yeah, this might be the problem. I think I'll be right back. I have another idea. I'm just gonna console log to see what's happening. Console log on here and the other one. I'm gonna do for all of the events. Created mounts. Oh, maybe it's because of this. Like the props changed because of the context. Because I'm passing the app as a context, but the thing is that it's console logging there when it's mounting, so there is something about the context here that it loses context. Yeah, this thing here. But I don't think that's what's causing the error. It's probably something else. Oh, maybe it's because of this thing. It starts as no and then it becomes this when it mounts. So it might be because this is mounting first. But then, yeah, maybe that's the case. I think that's the case. But then how would it work? Oh, because it still has that because it's no. So it still has the but then it doesn't make sense because I would be getting no when I console log there, here, or the props. That's what that was the case, it wouldn't make sense. The other thing that I can see, let me do this one first. That's the thing, when it's creating the application, it would be null here. Oh, the stage is null. Ah. Oh, that's why. So I do have the events, because the events is just the object, but when it creates it's null. Because it's creating the app here. I think that's the case. Hopefully that's the case. Like it has the app here as null. Canvas, let's see. The canvas exists. I'm just gonna print the application. Ah, so in the first time it renders. But that's weird. I guess that it has the events. So like by the time it creates the event listener, it binds to the null object, but then that wouldn't make sense because it wouldn't run. That's the thing. But I know what I have to do. I think I'm just gonna console log, like a console log here, and then I'm gonna console log the components did mount there, just see which one comes first. Just do the app here first. Oh, interesting. But why was I receiving this? Oh, it's just on the renderer. This is the wrong thing. I think it must exist. Otherwise it would break. Interesting. This is very interesting. Let's see. Yeah, so now it doesn't exist on the did mount. So that's why. It exists when it creates, but then it doesn't persist to the other cycles, the other parts of the cycle. But why though? Because it's just because of the context. Let me think about it. I think I have to understand, I have to follow the execution on the fiber to see how it's constructing the component. Then I have to think about how it's going to be the life cycle of the stage. But now I think I'm probably on the right track, I think. Because now I know that what the problem is. Hopefully that's the problem. So it's weird that the count is different though. That it shows null first and then it shows the element later. But it must have something to do with the rendering cycle, but then it doesn't console log on the other ones. It's very weird. So probably what is happening is that by the time it creates the thing, it has the renderer, but then when the component goes to the next phase of the cycle, it loses the renderer. But I don't understand why. It must have to do with the fiber. The way that the fiber is... The reconciler from the React-pixi is mounting and unmounting the components. Or managing the cycles. And it probably has to do with the context. Because I'm using the app context, so... Yeah, let me see. It does have access on both. So it's not because it's losing access after the first amount. It just doesn't have access on the other parts of the life cycle. So the question is why? Oh, it updates here. Probably on these updates. Oh, but if it has the events in the first part when it's creating, it means that this should come before the component is created, which means that this function is triggered because by that time you already have the context with the app. So it must be some other part. And then it's just passing the value. One thing that I can try is choose this thing instead of the other one as well. Maybe that's the problem. But if the problem was the context, then I think it would be failing at the start. Like it wouldn't even create the component because it wouldn't have access to the app. And the other components as well from the example also use the app context, so I don't think that's the problem. I think it's only an issue when you use the context from outside of the custom render. Then you can't do it. Yeah, I think that's something else, so I'm going to console log everything here, just see that's what other things are happening. Like the thing that I was trying to think about is this on mount here, because I'm not passing on mount there, so how is it possible that it creates the on mounts? Because it says it's coming from props, so it's probably a React component function. Yeah, whatever. I'll look into this later. Because I don't understand how it's possible that if I'm not passing it here as a props, but maybe we will just ignore that. Guess I can console log that later, to see. It might be because this is being triggered, but I'm not sure. So the render is the first thing that I guess triggered. Might be because of this ref here. So let me think. Like this might be the issue because when it's adding the elements here, it's re-rendering. So it is re-rendering. It is just on the other points. So when it mounts everything, it creates the events, but then it's a different reference, I think. But it might, like, it doesn't mount the component. Here it's just rendering and calling data update. Let me think, because this might change the reference or the application. The thing is that what I can do is create a function that puts the elements as it renders, but here it still fucks up, so it's not that.
we're actually
Yeah, so the question is what happens in the first time. There's only the first moments, so the first update, it fucks up. And then it has the reference again. And the other elements are not, the other parts of the stage are not triggered. It's very weird. So why would it fail on the first one? I'm gonna read the articles there. Just trying to think to see if I can get thinking about anything that I can try to solve. It's hard because I don't know if I understand really well. Like, what is the core of the issue? I think the problem might be because of this mount here, but I have no idea. I think like it's something related to the canvas, to the context with the canvas, the way that it creates and get children there, and then once it mounts, let's see the component will mount function. Like at some point it loses the context, I think. But it's weird because I'm receiving the app in the correct way. It's like, why would the events lose the context of the thing? Like, it might be something on some class that I don't know. On the hierarchy, that's the problem. Like, the issue is this thing here. It's very confusing to understand exactly what is getting. Like which renderer is getting. I don't understand the functions really well there. Like based on the stuff that I've seen, just looking at the source code, like it should return a string. I don't understand how it calls the string. And I can't console log to see what is incorrect there. Not incorrect, but how, like, what is returning? How is it possible that it's calling the thing that I think is supposed to be a string? On this page here, like, to me this should be a string when it gets to this point. So I don't understand how it creates. This is obviously not a string. So this is adding some stuff to the render, but it should be adding a string based on the sequence there that I saw. And like there's so many different classes that are inheriting. So like I might be missing something, because like this is the key of the issue, is that the options are created based on the render from the application. So, and then I'm getting the event system from that render. So is the event, is the DOM element of the event system that gets lost at some point. And I know that it has at some point as well, otherwise it wouldn't console log anything. At any point it would just be null from the gate. So I think that initially it has the context somehow, and then it loses the context. So maybe like the first time that it mounts, it creates in the right way, but then the second time is different because the way that it's going through the cycle is different. It's just some mounting here. The first time it renders and then goes through the functions, but this time it just goes through this and then it mounts, and then at this point it might lose context, I think. But then if that was the case, then it wouldn't create the second time. So maybe when I put, the reason why it works when I put the thing is not because, like, obviously it didn't solve the problem, it's just passing the problem because it's not destroying the thing. So when I don't put this, I get the error earlier because like the context is lost at that moment. But if I put this, then it doesn't destroy, and that's why it doesn't show, the error doesn't show up, but it still doesn't have the context. So I think that this is probably what is wrong here. Like it creates, in the first time that it mounts, it has the right context, but then when it unmounts, it loses the context. And then it becomes null the second time. I think that's the problem. I have to think about how to solve this. The problem is that I can't access these functions as well, because they're part of the React component props, I think. Yes, somewhere in these files, this fucking function. I guess I can just change here as well. I comment this stuff out and see what happens. But I'm gonna analyze this function next. I'll be right back. Oh, I think I get why. Because it initializes the event as no. So even though it exists, now I have to find the file. But I think I know what is going on. Maybe. I thought I know what's going on like several different times and changed my mind later. So where is the file? I guess I have to go here. Or maybe here. The problem is that it's initializing the element as null. That's why. So there's not a problem with the rendering. It's just that the first time is gonna be null because initialized. But then how does it change after that? Like maybe I'm massively overcomplicating this. There's also this thing here. What does it interactive does? Oh. This is a problem. It's gonna be really hard to find these things. Not sure if I want to spend a bunch of time searching for the documentation to understand what it does. Like, what is the point of setting the thing to true there? So I think one hacky thing that I can do is just change manually. So when it initializes this, the thing is, why is this thing working? It doesn't make sense. Like, if that was the problem, then you wouldn't add the event listener because it would just be no when it initializes. I guess that's what is confusing. So I think what I can try to do, just to test, is to see if I can set up. Like, the weird thing is that it works here. That's a problem. I think I'm gonna erase the console logs from other parts, so it doesn't get too many. But maybe it's not that it's working, it's just that it's adding to no here. First time. Where else do I have console logs? Here. Yeah, that's the thing. Like, I am getting the canvas when it's mounting. Do I have the thing off there? I guess I can close this in here. Yeah, I don't have the... Yeah, because I'm creating inside of here now. Let me see if I do it the other way. I still got the canvas, but now it fucks up on the beginning, on mount. So let's think about this. Because the other is still on mounting as well, I think. Because the world should be on mounting, I think. Maybe if I do it with the use effect here. It should be a mounting, yeah. So why does it fuck up when I have the custom components? It must be the fiber thing. The way the fiber is handling the custom component. That's the only explanation. But the thing is, like, that's not the fundamental problem because it's still fucking up the event here. So like it must be something else, but it should be related to the rendering cycle. Maybe it's because I have to. Yeah, but the thing is, this doesn't make sense because then you would work on the other way, maybe. Like initializing instead of the world, instead of creating this custom component. it's not just the events element. Apparently the sticker also is the same error. So anything related to the app. Let me see if I do. What happens if I... So the problem is probably the context in the app or something like that. And if I don't put events, it's gonna fuck it up. I think I have to pass events. It's gonna mess up here. Yeah. And this is the thing, it destroys the app before, I think. So it destroys the app and then it tries to do the thing again. That's the issue. Let's see, render the mounts, viewport mounted, as I will console log the other one as well. So it creates some mounts after renders, but here like still weird because it's giving no here, but here it says canvas. So I don't understand what is going on. I guess I should just put DOM element instead of putting here. So it does have the canvas, the beginning. And then that's where it fucks up. So render stage. So when it amounts, it destroys the reference that the viewport had from the app. So maybe if I use the bridge there, yeah, but I'm not sure if that would do anything. I think it wouldn't solve the thing. It's also really like complicated solution. I really don't like this. Want to avoid using this context bridge as much as possible. I might have to on the other contexts, the nodes, but if I can avoid here, it would be a lot better. Because I think the problem is not that like, it has access to the context. The problem is just that it creates different references, I think. So maybe, what if I created a use callback here inside of this one? Or use memo. I wonder if that would solve. Thing is, I don't know if I can do that or not. Because they don't have examples here. I think it has to be inside of this apply props property. But the thing is that even if I do it here, I think it doesn't work because it's on the like another part of the cycle. So like by the time that it calls create again, it's not gonna have time to call apply props, because create gets called first, I think. Yeah, it messes up here and then it has the canvas again. But how? Because after here you should have again the... Because it should create it. Yeah, but it is creating another instance, I guess, of the application. So the previous one gets lost. So yeah, when it destroys the application, it becomes null, and the event listener was binded to that in the first place. So when it tries to trigger, it lost the context, but then here it creates again because that's the second app that was created on the second mount. I think that's what's happening. Context provider component. So how can I solve this? That's the challenge. I guess I can also, let me think. There might be a way to set the app. Yeah, but the problem is, like, let's say I use state here at some point, and then I set the app using like in the first place I set, and then I keep the same app for the entire life cycle of the, like I use the same app for regardless of how many times this mounts and unmounts. I think that's not a good approach. This is not gonna update properly, I think. Like I need to figure out a way to but like the issue is, I need to figure out a way to call to destroy the thing before. That's the thing. Destroy the version, destroy the Pixi component before the app gets destroyed, before that this gets called component will mount. So I guess the answer is probably on the React reconciler. I have to see how can I do that. So I think I'm gonna write down the life cycle of both of them. Just see how does it, like, what is the order? And then after that I'm gonna see how can I change the React reconciler to change the order of the cycle, if there's a way to do that. The problem is that I'm not even sure if that's the issue or not. So I have to console log everything again. And these ones are already working. I guess I'm also gonna, I think, and maybe I should leave this just so I see if it is no at some point. So goes render. I also don't understand why render gets called twice. Yeah, that's the thing. So here is mounted, and then it unmounts the stage before. That's the issue. I think this, like, now I have a high degree of confidence that that's it. Because it's not only the element that is messing up, the ticker is messing up as well. So that should be on the app, I think, context. And I think this console logs here make it really clear. So like, it was the intuition that I had in the beginning. The problem is that it's just so confusing because there's so many classes involved. It's like so much stuff involved as well. And I don't know really well the React reconciler, the way that it works under the hood. So like, it becomes hard to know what is happening like under the hood. Sure. And like, this is the core of the issue, is the, like, there's two different cycles happening simultaneously. One is from the custom component, the other one is from the stage. But they both should be using the reconciler, I think. That's why it's weird. Because the way that they built this stuff, it should be built on the correct order already. But the thing is, I don't know how it works. Like how, if there's a way to decide the logic or of which thing gets, because it doesn't make sense for the children to be unmounted after the parent. And that's what's happening there, I think. What I can do as well is just change the logic of where, but it wouldn't help anyway. Like, there's no way for me to change the logic of the stage to make it work, because the events are going to be triggered in the same order. I think the only thing that I can do, or can try to do, is to see how, why is the wheel amount being called after the stage events. It should be, yeah, but the thing is, let me think about this. I guess it makes sense, because like, how is this component gonna know that the parent's gonna unmount? It wouldn't make sense for it to be mounted and then unmount. Maybe all I have to do is just implement on the, I'm gonna write down first, but maybe if I implement on the wheel unmount here. Yeah, but that's the thing, like, it's already implemented on the configuration, the destroy, and it doesn't work because it only calls this when this gets called. So the hacky thing that I can do is just destroy the, like, call this simultaneously with this stage here. So inside of the component wheel amount of the stage, I just call a function from the viewport. And then I'll have to think about a way to do that. But that doesn't feel like it's the right way. So I have to spend more time thinking about this. But I think now at least I'm fairly confident, not 100%, but I think that's what's happening here. The problem is the cycle, the order. Hey Noya. Oh, they probably took it down because of the music, but thanks for letting me know if you're listening. Maybe I'll write. Maybe I will write down. Are you listening? Type yes if you are. And even if it's not, we're gonna, yeah, And it sucks that I can't play music, otherwise they take it down. But it's very... Maybe I'll not play music anymore. And just live with the silence and play music for myself. But I don't really care that much, to be honest. Because at least the recording stays there, so... Apply props to mounted. So it's the same parts, the cycle. So in the first iteration it works because it's the create. The second iteration, because it already exists, is just some mount to the thing, and that's where it breaks. So they both follow the same pattern, and then this unmounts after, and then once this unmounts, the version of the apps, the context of the app is destroyed already. So let me think, how can I solve this? I guess I can use RAF. That's one way. So instead of accessing the app through the context, I access through the RAF. I'm not sure if that's the best. Yeah, what I have to do is just figure out a way to access the app so that I have the correct version regardless of the... Like, it has to update at each cycle, but then it should allow me to remove after the stage has been removed. So how can I do that? And it seems like it's kind of a... The thing is, I'm not really sure if it's a flaw in the design, because it's like two different libraries. But maybe it's supposed to... Like, it used to work in the past, because... Yeah, I don't understand. Maybe, like, I'm getting something wrong as well. But these console logs here make it pretty clear, I think, that this is what's happening. That's the issue. But then how did it used to work? That's the thing that doesn't make sense. Because before, I think it was working based on the examples there. So what was the difference? Because it was still using the app. And I remember that I saw some examples. I think it was this one. Yeah, here it is using the app still. So why does it work here? Oh, maybe it's because I have to do another component. Maybe that's what I'm messing up. And here it doesn't work. He's also using another library for the user, using lat React-pixi. So I think I'm gonna try to do this way that he's doing here. But it should be the same thing, I think. Because I'm just wrapping, but it's pretty much the same. But then I don't understand like why does his version work here? Because he's using the app. Maybe it's because of this. The use app from the inlet is different. Oh, he's using the stage from. It should be the same, I think. Same thing. But I don't understand why his stuff works. Because it's essentially the same thing that I'm doing. Maybe the engine can be, but I think like the engine shouldn't have anything to do. Or maybe the mouse, but I also think that's not the case. Because I remember commenting out the mouse and it still doesn't work. I think it is the life cycle, but it's weird that his version works even though he's accessing the app as well. But like, it doesn't make sense to me. Because if it was just the change from interactions to events, then like it should still work. It should still break if it was the life cycle thing. And I'm also wrapping the use app into another component as well. So it is pretty much the same. The only difference is the way that the component is, but pretty much the same thing. I wish I could see the source code though. Yeah, it doesn't let me. But like the concern that I have is that I'm focusing on the wrong thing. So even if I spend a bunch of time in trying to make it work there, and I make it work, it's like, I don't know. Because if it was the lifecycle, it shouldn't be working in this way as well. So I don't understand. Like, obviously something changed on the libraries, but unless that the changes they made changed the way that the lifecycle works, that could be the case. Like the change, like when they changed the Pixi viewport to use the events, it changed the way that the lifecycle. But I don't see why that would be the case, because like the Pixi viewport class doesn't have anything to do with lifecycles. It's just the wrapper that it does, the Pixi component. And it seems that it is something that is related only to the Pixi, React-pixi library, the way that the life cycles are connected there. Let me see. If I change I think I can't change the way that I'm initializing the class, because the only other place would be the mountain, and then I'm gonna get into the same problem. It's just gonna be a little bit further. Like, did I copy everything? Real mounts. Yeah, render components, did mount, get children, set interaction, range, render stage, create, apply props, import mounted, component will mount, point did mount, get children, set interaction, will mount. Like if I initialize the viewport in the viewport mounted, it would be the same thing. So the question is, how can I put this will mount after the component will mount? So I think I have to study the fiber to see how it renders the. So the question is, how does fiber renders? Oh, this is the thing. This is getting from these prop types. Yeah, so it just does an empty function if you don't pass anything. And so it removes everything and then updates the container. So I have to see update container function. I think this is the key here. Because inside of the fiber should exist the children, which the other components is going to be a part of. So there's some problem with the updates. Amount node is the Pixi fiber create container. So create container, update container. I have to understand how these two functions work. So I think I'm gonna read this stuff here. I'll be right back. And when I come back, I'm gonna read this stuff and I'm gonna try to see. So the main thing that I have to do is see how can I organize the sequence of events there so that the unmounting happens before the app gets destroyed. And I think that's gonna probably solve the issue there. So hopefully. So yeah, be right back. I also think that I'm gonna spend only more 19 minutes here till closes 8 hours. Then I'm gonna stop because I'm already tired. And it's really difficult, not gonna lie, to solve this. So hopefully I can figure it out at some point. The problem is that I have to do the update for Buildspace. So like I don't know what I'm gonna do tomorrow. Well, I'm gonna have to decide. Maybe I'll still try tomorrow, and then if I can't do it by tomorrow, then I'll change the UI or just something like that, and then do that as the update. But obviously I like the thing that I care the most now is to figure this stuff out because it's very important. Like I need to be able to add the event listeners, and I think only after that I should focus on improving the visualization, because I think one of the big parts of this is being able to move around the graph. I think it's very essential that I get this down. And then the visualization is the second part, I think. Second important part.
React Reconciler. This is an experimental package for creating custom React renders. Its API is not as stable as that of React, React Native, or React DOM, and does not follow the common versioning scheme. Use it at your own risk. Usage. Const reconciler equals require React Reconciler. Const host config equals // you'll need to implement some methods here. // see below for more information and examples. Const my renderer equals reconciler host config. Const render public equals render element container callback // call my renderer update container to schedule changes on the routes. // see React DOM, React Native, or React Art for practical examples. Semicolon module exports equals renderer public API. Practical examples. A. Host config is an object that you need to provide, and it describes how to make something happen in the host environment. E.g. DOM, canvas, console, or whatever your rendering target is. It looks like this. Const host config equals create instance type props // for example DOM renderer returns a DOM node // supports mutation true // it works by mutating nodes append child parent child // for example DOM renderer would call append child here / for an introduction to writing a very simple custom renderer, check out this article series, Building a Simple Custom Renderer to DOM, Building a Simple Custom Renderer to Native. The full list of supported methods can be found here. For their signatures, we recommend looking at specific examples below. The React repository includes several renderers. Each of them has its own host config. The examples in the React repository are declared a bit differently than a third-party renderer would be. In particular, the host config object mentioned above is never explicitly declared, and instead is a modular code. However, its exports correspond directly to properties on a host config object you need to declare in your code. React Art and its host config, React DOM and its host config, React Native and its host config. If these links break, please file an issue and we'll fix them. They intentionally link to the latest version since the API is still evolving. If you have more questions, please file an issue and we'll try to help. And incomplete reference. At the moment, we can't commit to documenting every API detail because the host config still changes very often between releases. The documentation below is provided in the spirit of making our best effort rather than an API guarantee. It focuses on the parts that don't change too often. This is a compromise that strikes a balance between the need for a fast-paced development of React itself and the usefulness of this package to the custom renderer community. If you notice parts that are out of date or don't match how the latest stable update is behaving, please file an issue or send a pull request, although response might take time. Modes. The reconciler has two modes, mutation mode and persistent mode. You must specify one of them. If your target platform is similar to the DOM and its method similar to append child, remove child, and so on, you'll want to use the mutation mode. This is the same mode used by React DOM, React Art, and a classic React Native renderer. Const host config equals // supports mutation true //. If your target platform has immutable trees, you'll want the persistent mode instead. In that mode, existing nodes are never mutated, and instead every change clones the parent tree and then replaces the whole parent tree of the root. This is the node used by the new React Native renderer, codename Fabric. Const host config equals // supports persistence true // depending on the mode.
Let's see which one of this is support. Yeah, so it is the mutation one. Mutation, persistent, false.
Reconciler will call different methods on your host config. If you're not sure which one you want, you likely need mutation mode. Core methods: create instance type, props, root container, host context, internal handle. This method should return a newly created node. For example, the DOM renderer would call document.createElementType here and then set the properties for props. You can use root container to access the root container associated with that tree. For example, in the DOM renderer, this is useful to get the correct document reference that the root belongs to. The host context parameter lets you keep track of some information about your current place in the tree. To learn more about it, see get child host context below. The internal handle data structure is meant to be opaque. If you bend the rules and rely on its internal fields, be aware that it may change significantly between versions. You're taking on additional maintenance risk by reading from it and giving up all guarantees if you write something to it. This method happens in the render phase. It can, and usually should, mutate the node it is just created before returning it, but it must not modify any other nodes. It must not register any event handlers on the parent tree. This is because an instance being created doesn't guarantee it would be placed in the tree. It could be left unused and later collected by GC. If you need to do something when an instance is definitely in the tree, look at commit mount instead. Create text instance text, root container, host context, internal handle, same as create instance, but for text nodes. If your renderer doesn't support text nodes, you can throw here append initial child parent instance child. This method should mutate the parent instance and add the child to its list of children. For example, in the DOM this would translate to a parent instance append child. Call. This method happens in the render phase. It can mutate parent instance and child, but it must not modify any other nodes. It's called while the tree is still being built up and not connected to the actual tree on the screen. Finalize initial children instance type, props, root container, host context. In this method, you can perform some final mutations on the instance. Unlike with create instance, by the time finalize initial children is called, all the initial children have already been added to the instance, but the instance itself has not yet been connected to the tree on the screen. This method happens in the render phase. It can mutate instance, but it must not modify any other nodes. It's called while the tree is still being built up and not connected to the actual tree on the screen. There's a second purpose to this method. It lets you specify whether there's some work that needs to happen when the node is connected to the tree on the screen. If you return true, the instance will receive a commit mount call later. See its documentation below. If you don't want to do anything here, you should return false. Prepare update instance type, old props, new props, root container, host context. React calls this method so that you can compare the previous and the next props and decide whether you need to update the underlying instance or not. If you don't need to update it, return null. If you need to update it, you can return an arbitrary object representing the changes that need to happen. Then in commit update, you would need to apply those changes to the instance. This method happens in the render phase. It should only calculate the update, but not apply it. For example, the DOM renderer returns an array that looks like prop 1, value 1, prop 2, value 2 for all props that have actually changed, and only in commit update it applies those changes. You should calculate as much as you can in prepare update so the commit update can be very fast and straightforward. See the meaning of root container and host context in the create instance documentation. Should set text content type props. Some target platforms support setting an instance's text content without manually creating a text node. For example, in the DOM, you can set node.text content instead of creating a text node and appending it. If you return true from this method, React will assume that this node's children are text and will not create nodes for them. It will instead rely on you to fill the text during create instance. This is a performance optimization. For example, the DOM renderer returns true only if type is a known text only parent, like text area, or if props.children has a string type. If you return true, you will need to implement reset text content too. If you don't want to do anything here, you should return false. This method happens in the render phase. Do not mutate the tree from it. Get root host context root container. This method lets you return the initial host context from the root of the tree. See get child host context for the explanation of host context. If you don't
I think I need to see like what is being called there. Because the will amount should be triggered by the stuff that happens on the stage, I think. Because it's only gonna change based on the state, I think. So whenever you have an event, you trigger the set state, and then based on the set state, it's gonna decide what are the things that are gonna be updated on the state of the React. So in this case, using the custom renderer, so whatever part of the lifecycle is there, then it's gonna trigger those parts, and then based on those parts, it's gonna execute the logic of the function, the functions there. So this logic here so I have to see this part here. So the first one works, so I have to see on the render stage what happens. Yeah, the problem is that component we won't mount is the thing that destroys the app context. So this destroys the app. Let me see here, destroy. Yeah, so if it erases the stuff, and then I think only on the renderer. So then it calls the thing again. But then when it calls the other stuff, it has another app, I think. So right after that, it calls component did mount. One component did mount, which is gonna create another app. So by that point, the previous app doesn't exist anymore. Let's see. So it's on this phase, I think. Then got children here. Yeah, so the question is why on this function? Yeah, what would be the props here? Why would it have the old version of the custom components? Like why wouldn't it create another one here? So it mounts the other one later. That's the thing that is weird. So it must be a mistake on the component we will mount function, I think. So get children, then after the render stage, which is here. Not sure if that's the... I got children, then because this stuff here. So the question is, why does it call the amount after this one? This is what doesn't make sense. As it's only because when it's rendering, then it has to mount the previous one to mount the new children, maybe. But then it should do that on the get children. But maybe it only does that when it's only calls this function here, the render function. Yeah, it's really hard to know. I think I'm just gonna read this stuff and I'm gonna stop for today and continue to try. Just solve this tomorrow.
Intend to use host context. You can return null. This method happens in the render phase. Do not mutate the tree from it. Get child host context parent host context type root container. Host context lets you track some information about where you are in the tree so that it's available inside create instance as a host context parameter. For example, the DOM renderer uses it to track whether it's inside an HTML or an SVG tree because create instance implementation needs to be different for them. If a node of this type does not influence the context you want to pass down, you can return parent host context. Alternatively, you can return any custom object representing the information you want to pass down. If you don't want to do anything here, return parent host context. This method happens in the render phase. Do not mutate the tree from it. Get public instance determines what object gets exposed as a ref. You'll likely want to return the instance itself, but in some cases it might make sense to only expose some part of it. If you don't want to do anything here, return instance. Prepare for commit container info. This method lets you store some information before React starts making changes to the tree on the screen. For example, the DOM renderer stores the current text selection so that it can later restore it. This method is mirrored by reset after commit. Even if you don't want to do anything here, you need to return null from it. Reset after commit container info. This method is called right after React has performed the tree mutations. You can use it to restore something you've stored and prepare for commit. For example, text selection. You can leave it empty. Prepare portal mount container info. This method is called for a container that's used as a portal target. Usually you can leave it empty. Schedule timeout fn. Delay. You can proxy this to set timeout or its equivalent in your environment. Cancel timeout it. You can proxy this to clear timeout or its equivalent in your environment. No timeout. This is a property, not a function, that should be set to something that can never be a valid timeout ID. For example, you can set it to -1. Supports microtask. Set this to true to indicate that your renderer supports schedule microtask. We use microtasks as part of our discrete event implementation in React DOM. If you're not sure if your renderer should support this, you probably should. The option to not implement schedule microtask exists so that platforms with more control over user events, like React Native, can choose to use a different mechanism. Schedule microtask fn. Optional. You can proxy this to queue microtask or its equivalent in your environment. Is primary renderer. This is a property, not a function, that should be set to true if your renderer is the main one on the page. For example, if you're writing a renderer for the terminal, it makes sense to set it to true, but if your renderer is used on top of React DOM or some other existing renderer, set it to false. Get current event priority. To implement this method, you'll need some constants available on the special React reconciler / constants entry point. Import, discrete event priority, continuous event priority, default event priority, from React reconciler / constants, const host config equals / get current event priority, return default event priority / const my renderer equals reconciler host config. The constant you return depends on which event, if any, is being handled right now. In the browser, you can check this using window.event and window.event.type. Discrete events, if the active event is directly caused by the user, such as mouse and keyboard events, and each event in a sequence is intentional, e.g., click, return discrete event priority. This tells React that they should interrupt any background work and cannot be batched across time. Continuous events, if the active event is directly caused by the user but the user can't distinguish between individual events in a sequence, e.g., mouse over, return continuous event priority. This tells React they should interrupt any background work but can be batched across time. Other events, no active event. In all other cases, return default event priority. This tells React that this event is considered background work, and interactive events will be prioritized over it. You can consult the get current event priority implementation in React host config.js for a reference implementation. Mutation methods. If you're using React in mutation mode, you probably do. You'll need to implement a few more methods. Append child parent instance, child. This method should mutate the parent instance and add the child to its list of children. For example, in the DOM this would translate to a parent instance.append child child. Call. Although this method currently runs in the commit phase, you still should not mutate any other nodes in it. If you need to do some additional work when a node is definitely connected to the visible tree, look at commit mount. Append child to container child. Same as append child, but for when a node is attached to the root container. This is useful if attaching to the root has a slightly different implementation, or if the root container nodes are of a different type than the rest of the tree. Insert before parent instance, child, before child. This method should mutate the parent instance and place the child before child in the list of its children. For example, in the DOM this would translate to a parent instance.insert before child, call. Note that React uses this method both for insertions and for reordering nodes. Similar to DOM, it is expected that you can call insert before to reposition an existing child. Do not mutate any other parts of the tree from it. Insert in container before child, same as insert before, but for when a node is attached to the root container. This is useful if attaching to the root has a slightly different implementation, or if the root container nodes are of a different type than the rest of the tree. Remove child parent instance, child. This method should mutate the parent instance to remove the child from the list of its children. React will only call it for the top level node that is being removed. It is expected that garbage collection would take care of the whole subtree. You are not expected to traverse the child tree in it. Remove child from container, child. Same as remove child, but for when a node is detached from the root container. This is useful if attaching to the root has a slightly different implementation, or if the root container nodes are of a different type than the rest of the tree. Reset text content instance. If you return true from should set text content for the previous props, but return false from should set text content for the next props, React will call this method so that you can clear the text content you were managing manually. For example, in the DOM you could set node.text content equals. If you never return true from should set text content, you can leave it empty. Commit text update text instance. Pref text, next text. This method should mutate the text instance and update its text content to next text. Here, text instance is a node created by create text instance. Commit mount instance, type, props, internal handle. This method is only called if you return true from finalize initial children for this instance. It lets you do some additional work after the node is actually attached to the tree on the screen for the first time. For example, the DOM renderer uses it to trigger focus on nodes with the autofocus attribute. Note that commit mount does not mirror remove child 1-to-1 because remove child is only called for the top level remove node. This is why ideally commit mount should not mutate any nodes other than the instance itself. For example, if it registers some events on some node above, it will be your responsibility to traverse the tree and remove child and clean them up, which is not ideal. The internal handle data structure is meant to be opaque. If you bend the rules and rely on its internal fields, be aware that it may change significantly between versions. You're taking on additional maintenance risk by reading from it and giving up all guarantees if you write something to it. If you never return true from finalize initial children, you can leave it empty. Commit update instance, update payload, type, pref props, next props, internal handle. This method should mutate the instance according to the set of changes in update payload. Here, update payload is the object that you've returned from prepare update and has an arbitrary structure that makes sense for your renderer. For example, the DOM renderer returns an update payload like prop1, value 1, prop2, value 2 from prepare update, and that structure gets passed into commit update. Ideally, all the diffing and calculation should happen inside prepare update so the commit update can be fast and straightforward. The internal handle data structure is meant to be opaque. If you bend the rules and rely on its internal fields, be aware that it may change significantly between versions. You're taking on additional maintenance risk by reading from it and giving up all guarantees if you write something something to it. Hide instance. This method should make the instance invisible without removing it from the tree. For example, it can apply visual styling to hide it. It is used by suspense to hide the tree while the fallback is visible. Hide text instance. Same as hide instance, but for nodes created by create text instance. Unhide instance. Props. This method should make the instance visible, undoing what hide instance did. Unhide text instance. Text. Same as unhide instance, but for nodes created by create text instance. Clear container. This method should mutate the container root node and remove all children from it. Persistence methods. If you use the persistent mode instead of the mutation mode, you would still need the core methods. However, instead of the mutation methods above, you will implement a different set of methods that performs cloning nodes and replacing them at the root level. You can find a list of them in the persistence section listed in this file. File an issue if you need help. Hydration methods. You can optionally implement hydration to attach to the existing tree during the initial render instead of creating it from scratch. For example, the DOM renderer uses this to attach to an HTML markup. To support hydration, you need to declare supports hydration true and then implement the methods in the hydration section listed in this file. File an issue if you need help. Hello World Custom React Renderer. In the previous post, we saw some introduction to custom React renderers. Let's look at building a Hello World Custom React Renderer. We are going to start backwards from a React app and fill out the missing pieces for our implementation. We are going to create a super small, very basic DOM renderer. It goes nowhere near realizing all the performance optimizations, and the implementation is most probably not the 100% correct way to do it. Create a new React project using create React app and start it. Create React app Hello React Custom Renderer at Hello React Custom Renderer yarn start. You should have your app running at http://localhost:3000/2. Let us add a simple counter. Modify the app.js file to as shown below. This counter example will serve as a test for renderer implementation. 2. Let us replace React DOM usage with our custom renderer in the index.js file. Import React from React''// import React DOM from React DOM. Import my custom renderer from /my custom renderer. Import ./index.css. Import app from ./app. Import register service worker from ./register service worker '/ React DOM.render app greater than document.getElement by root. My custom renderer.render app greater than document.getElement by root. Register service worker. 3. Add React reconciler package to the project. Yarn add React reconciler. Create a new file named my custom renderer.js with code as shown below. Render function is the only public interface that renderers need to implement. Inside this, we use the React reconciler. In our index.js, we use the render function as my custom renderer.render app greater than document.getElement by root. This render function takes 3 arguments. React element in our case it is our app React element. DOM element is the DOM element which has the id root into which React element will be rendered. The third argument callback is optional that is called after the component app is rendered or updated. In our case we omit that. If you are confused with terms component, element, https://reactjs.org/blog/2015/12/18/React components elements and instances.html should be help clarifying a bit. Host config is the object where we need to implement the functions that will be used by React reconciler. There is no documentation or guide specifically for React reconciler other than looking at source code and other implementations. At this point, we will throw in with the following error. Now is a function React reconciler expects in host config. This function seems to be used in React reconciler for scheduling updates to the target. We will just return the JavaScript date.now for now. Const host config equals now date.now. At this point, we should be thrown with the following error. Get root host context is another function that React reconciler expects in host config. The intent for this function seems to be for maintaining some information if needed by the renderer implementation. We are going to provide an empty function for now. Const host config equals now date.now. Get root host context equals greater than. After repeating this reverse engineering for a few more steps and adding empty stubs, host config looks like this. Const host config equals now date.now. Get root host context equals greater than. Prepare for commit equals greater than. Reset after commit equals greater than. Get child host context equals greater than. Should set text. At this point, all the errors seem to have gone, but nothing renders on the screen. Looking at different implementation of renderers, it turns out we need set a property called supports mutation to true. Update 1. This indicates the React reconciler that the target e.dom UI API supports mutation of the UI tree X. Operations like append child, remove child, etc. Const host config. After we add this function, we get the following error. Let us add append child to container to host config. After this, the error seems to have gone, but we are back to empty screen. I added some console log to figure out what functions are being called. It looks like this. My custom renderer.js:7 get root host context me custom renderer.js:16 get child host context me custom renderer. Let us try to replace the empty function stubs by what React reconciler expects to be. The functions can be grouped into different categories. Create instance type, new props, root container instance, underscore current host context, work in progress. This is where React reconciler wants to create an instance of UI element in terms of the target. Since our target here is the DOM, we will create document.createElement, and type is the argument that contains the type string like div or img or h1, etc. Update 1. The initial values of DOM element attributes can be set in this function from the new props argument. Create text instance. This function is used to create separate text nodes if the target allows only creating text in separate text nodes. UI tree operations. Append initial child maps to DOM element.append child. This function gets called for initial UI tree creation. Append child maps to DOM element.append child. Similar to append initial child but for subsequent tree manipulation. Remove child maps to DOM element.remove child. Append child to container maps to DOM element.append child. Gets called in the commit phase of React reconciler. Update prop operations. Finalize initial children. This function can be left empty. Prepare update. This is where we would want to diff between old props and new props and decide whether to update or not. In our implementation, we just set it to true for simplicity. Commit update DOM element, update payload, type, old props, new props. This function is used to subsequently update DOM element attributes from the new props values. That's it. We have a super small tiny hello world React renderer working. You can find source code of the repo at https://github.com/agenthunt/hello React custom renderer. Update November 6, 2018. Updated based on some clarifications received from Dan Abramoff. Thanks Dan. More from Shailesh. Solving problems, making software better. Intrigued by elegant solutions. https://twitter.com/agent_hunt. Solving problems, making software better. Intrigued by elegant solutions. https://twitter.com/agent_hunt.
Yeah, so I think that it's probably gonna be these functions here that I have to look into. And I think that it is the problem is the order of events here. As I'm mounting before. The custom component is mounting after the stage mounts. So it destroys the version of the reference of the app that the thing has, so we can't mount. And I think that it's gonna be the same issue if I do this, but then it just delays the problem. Because then it works because I'm not destroying. But then when you're gonna click, trigger the events, you have the wrong version of the app. So I have the event where it doesn't exist anymore, I think. But it's weird because this way it should be working. Like maybe as it goes through, like at this point it should have the correct reference for the canvas after creating here a new one. But when you click here, I think that you're still gonna get the same error even if I don't click there. Stage render, my prompts. And that's another problem because it is going through the cycles here, but it doesn't do anything with the custom one. I guess it does this apply props, so. And here it has mounted. I think it's on the get. Like the way that it's probably supposed to work is with the get children, I think. That each time that it does the cycle, it gets the new children. But then if you instantiate a class that has that reference to the app, it fucks up. Like the other thing that I can try is calling something else, like not using the viewport class and just using the app context, and then trying to call a method of the thing. I could try to initialize the methods as well on the mounted, but not sure if that's gonna work or not. Probably it won't work because it's still the same problem. Let's see if I just do this. Yeah, it fucks up. Because the reference is not the same, even though it creates here. Because I think at the moment that it creates the event listener, it's creating with the reference that is deleted later. That's the thing. So when it triggers the function, it doesn't exist anymore. I've already exhausted now, so I'm gonna continue to try to solve this tomorrow.